Un po' di gente, comunque siamo in stazione a Ginevra, a Cornaven, quindi sono 20 minuti circa di tram per il CERN, arriveremo lì, faremo un po' un giro, dice un po' se ci vedete, nel frattempo a un certo punto switcheremo in inglese.
Sì.
Ora stiamo andando in italiano perché comunque...
inglese ragazzi,
mica cazzi. We talk in English just because maybe we expect some international. Oh, already Luca Cat is there. Ciao Luca Cat, ciao Jax. Thank you very much for being here, guys. We really appreciate the fact that you're here to help us with the possible big amount of people that is around. So yeah, let us know if everything works correctly, if the subs are alright. Abbiamo tolto gli alert, ok, no? Possiamo parlare in italiano perché è così. Tra l'altro è arrivato il tram.
Oh mio Dio!
È arrivato il tram, sta arrivando, eccolo qua. Guardate il tram con la scritta CERN e le bandierine del CERN sopra, che figata. Che figata. Ed è tra l'altro strapieno, non c'è nessuno. Vabbè. Entriamo da una parte. Ok. Siamo un po' stretti, forse. Aspettate. Un po' buio.
Benvenuti sulla linea B.
Benvenuti sul 18 che porta da Ginevra a Cornavan. Ciao Gaucci, ciao Appius, ciao a tutti,
belli.
ciao Bielli. Siamo molto bui.
Siamo bui perché
abbiamo preso il
è il nostro... Adesso arriva.
Eccole qua le luci, perfetto.
Hai smarmellato.
Abbiamo smarmellato.
Perché avessero spento le luci del tram? Perché era un'atmosfera un po' più...
Grazie per l'host, Luca Gat.
Grazie Luca.
Già...
Beh, diciamo che si vede che c'è gente.
Si vede, eh? Noi devo prendere un po' la mano con il...
Sì, se ci vedete bene, se non ci vedete tanto.
Viscio, ciao Viscio. Okay, so we will switch from English to Italian or Italian to English, whatever, at some point during the stream, because it's gonna be a mixed stream. So what we're gonna do, I'm gonna explain this in English. I think we'll speak in English for 90% of 90% of the stream.
Only the jokes in Italian.
But the jokes are in Italian. Thank you, Jax. Thank you for the host, guys. Yeah, there's people looking at us in a very weird way. And basically every 5 years or something, let's say random stuff.
Yeah.
Just get in, like it's your workplace. So it's one of those occasions in which
it's a very big event.
It's a very big
There's a
event.
lot of people. Like
There's a shitload of people. It's very crowded. It's very interesting. Last time I worked as a volunteer because they even gave me like the EasyJet T-shirt. You know, the purple T-shirt that looks like you're an hostess from EasyJet. I didn't bring it today because
Why? Why not?
Why not? I don't know. It was okay. We're heading there. We kind of hoped that the tram was a bit more free. But as you can see, it's kind of crowded. But we wanted to share this moment also. Yeah, the full experience, exactly.
Good morning, going to CERN.
Buongiorno Giorgetti, buongiorno Iaci, avremo ospiti. Dunque, avremo sicuramente Pisani, collateral che mo andiamo a prenderlo.
Andiamo a
raccattare Pisani. Mo dobbiamo arrivare al CERN, dobbiamo prendere il pass stampa e poi dobbiamo recuperare Pisani che stacca all'1:30. che stacca all'1:30 perché sta lavorando da volontario al CERN in questi giorni, quindi
non si ferma mai.
andiamo a recuperarlo. Mega, ciao pezzo
di nerd, come va?
Dunque,
vabbè, diciamo che
c'è stato.
Sì, siamo vicini, dovevamo stare vicini, quindi
sì, vabbè, no, mi dispiace solo che fracassiamo il cazzo al prossimo, senza pietà. Vittu sembra un tantino sconvolto. Ma che Vittu si è laureato?
Ragazzi, io giovedì mi sono laureato, sono ubriaco da 2 giorni, ieri sera ho fatto tardi facendo maratona film che non vi racconterò.
Maratona con i film.
Un film in russo
con sottotitoli in tedesco.
Sottotitoli, esatto. Qui non ci si capiva, non ci si capiva, diciamo.
Io per esempio ci ho capito un cazzo. Perfetto. Quindi niente, ora stiamo andando. Grazie per il resub, Rastmet, per 16 mesi. Abbiamo la robina in basso qua sotto che dice sostanzialmente cosa sta succedendo. Abbiamo tolto gli alert, altrimenti temevamo fosse un
Grazie
casino.
mille degli auguri.
Sì, hai preso la specialistica,
esatto.
specialistica in fisica delle particelle, giusto?
Sì.
Quindi ora puoi
Quindi ora
andare a CERN
sto tornando sul luogo del misfatto.
con cognizione
come
di
io si
causa.
festeggia così, no? Quando ti liberi di qualcosa ci torni subito.
Perché ricordiamo che comunque già mi fa male la...
Vuoi che ti...
No, scusa. No, devo togliermi questo...
Vuoi che ti massaggi la spalla?
Massaggiami la spalla mentre reggo. Così. Già mi fa malissimo. Aspetta, devo togliermi sto coso. Esatto, maratona film, l'esorciccio, Giovannona coscia lunga e la polizia si incazza.
Magari qui c'è gente che è troppo
E al,
in alto.
e al terzo giorno la polizia si incazzò veramente. Ok, quindi facciamo un piccolo recap in italiano e in inglese del CERN.
Allora,
Cosa fa il CERN?
il CERN si occupa di ricerca da tutti i lati, cioè quello che è famoso è l'acceleratore principale, la ricerca di fisica delle particelle, ma in realtà poi questo si va a cascata su un sacco di applicazioni anche diciamo per persone normali, dalla fisica medica, da tecnologie per anche cose di droni sviluppato ultimamente, poi non ne so tutte quante.
Sì, comunque
Però tanta.
diciamo ricerca
È
nel
il
campo
centro
della
europeo.
fisica delle particelle, però a tutto campo, certo, c'è l'LHC che è questo acceleratore enorme circolare, anzi un collider, perché fa collidere sostanzialmente pacchetti di protoni, ma c'è anche tanta altra ricerca. In realtà noi oggi ci concentreremo più su quella,
Sì,
perché
basta
ovviamente
con le cose che si sanno.
c'è
avete
Atlas.
tutti seguito Big Bang.
Vabbè, se Atlas, cioè insomma, si è visto, si è rivisto, così. Invece noi vorremmo portarvi a vedere, insomma.
Esatto, poi c'è il tunnel che arriva al Gran Sasso, quello è comodissimo, infatti, chi torna nel centro Italia.
Esatto, 700 che è comodissimo, tu arrivi e sei all'Aquila.
Puoi
e
anche
poi-
addormentare perché tanto
Tanto è dritto, capito? C'hai i binari,
Esatto.
c'ha le cose. Tutto così siamo ancora a Servezza.
Per questo non arriveremo mai.
Non arriveremo mai.
Spero solo non ci sia
amici.
traffico lì vicino, però.
Speriamo.
Vabbè, è bello perché è il centro europeo, dopo la seconda guerra mondiale che c'era da riprendere questi americani che si erano presi tutti i geni che se ne andavano e hanno deciso di unire gli sforzi di ricerca di diverse nazioni e hanno deciso di mettersi in Svizzera non per motivi economici, soltanto perché erano neutrali sicuramente.
Comunque,
Perché non costruiscono un CERN anche in Italia?
che è uno sforzo collettivo di tante nazioni. L'Italia da sola non basterebbe a reggere lo sforzo economico tale da permettere quel tipo di ricerca lì. Perché
Rappresenta tutte quante le nazioni che contribuiscono, poi adesso si sta allargando anche fuori dalla comunità europea, ci sono tantissime nazioni che contribuiscono anche perché hanno ritorno, perché gli scienziati che fanno parte delle nazioni che finanziano il CERN hanno poi un accesso privilegiato, sono comunque un attimino...
sì, sono stati membri e quindi possono prendere contratti, possono prendere. Io il voto alla location. Questo Alessandro
Guarda,
Borghese che
siete
torna.
fortunatissimi che non si sentano gli odori. Location a alto livello.
Location è 10, CERN location è 10.
E l'Italia è una delle nazioni più rappresentate.
Sì, penso sia la seconda o la terza, se non erro. Tra l'altro
Poi
fateci
varia
sapere
un
se
pochino,
vedete bene lo stream, perché siamo comunque con una scheda così, oggi sarà affollato, abbiamo un po' di piani di backup nel caso dovesse andare tutto simpaticamente a peripatetiche, però insomma si sente un bambinetto che c'ha.
Sono io però.
Vittorini che spiega il
Come
CERN.
mi sto dicendo una cosa.
CERN.
Grazie per avermi detto.
Sì, si pronuncia CERN.
Pronuncia CERN.
CERN.
Yes.
Tra l'altro nel frattempo siamo in Veneto.
Siamo in 100 a ballare l'alligato.
Siamo già in centro.
Una donna.
Infatti sì, mamma santa.
Diciamo che avevo tutta la densità di questo tram, però va benissimo.
C'è uno con una maglietta Just Vomit che vorrei tantissimo far vedere. Sì, un po'
Cerchiamo di
in sé.
tenerla privata questa trasmissione.
In
Cioè
sé.
vedete in realtà la strada di Torino di tutte le persone.
Esatto, ci abbiamo fatto apposta. Siamo in home di Twitch, infatti.
Grandi.
Allora, so we can explain a bit in English in case we have some English speaking people right now. Oh god, people have to get up. Nobody has to get up.
Everyone explain itself.
So, what is CERN? CERN is
CERN is the European Center for Nuclear Research.
nuclear research.
Okay. and he's a European organization, original European. Now he's several members from all across the world, and is where we have worked, studied for.
I worked there for 5 years.
He's an expert. For more or less a year. I was with the University of Geneva, and we also have done some research at CERN. So
Ti va di reggere un attimo te? Perché io già mi sta smontando la spalla. Grazie. Non mi fa niente, devi reggerlo. So yeah, it's mainly focused on particle physics, of course, and it's one of the biggest research laboratories in the world. It's a collaboration between almost every state in Europe plus some states from outside, which cannot be member states. They're kind of associate members, but they can help. So it's a pretty nice international environment. It's a unique atmosphere. And now today we're going for the CERN Open Days, which is like a
mega event,
exhibition, the various experiments, or in general the various kind of research. Because in order to be able to build the biggest and most complex machine in the world, one needs a lot of know-how on very different kind of like engineering, like mechanical engineering, electronic engineering, radiation engineering. People getting on the tram.
Sorry, guys.
Okay.
This is real life. Huh? We're taking it with us to our.
Yeah, exactly. We're on the way now. In this moment, we're on the way to CERN. People are looking at us because we're speaking with the phone, and so we're going there. We're almost there, actually, more than midway. Maybe we can show you a bit also the outside, what it looks like while we speak and explain CERN. So we can switch to the front camera and show you, oh, look at that! That was pretty cool.
Geneva.
This is the Geneva, let's say, not countryside, but kind of suburbs. Okay, we're moving out toward France because, as you might know, Geneva is on the border between France and Switzerland. So, yeah, basically there's like a tram that connects directly Geneva station with the.
Real life, your feelings, your problem,
exactly. Perfect. We're going.
Real time experience.
Thank you, Darian, for the sub. It's okay. Great. So I'll show you this. We will try to avoid showing other people because it doesn't seem
it's
that
not
nice.
very polite.
It's not very polite. Here you can see the things. Tell us if the video and audio is okay because it's kind of weird. Okay, we can switch back here. There's nothing to. Yeah, perfect. So we just wanted to show you the thing. How long until we reach CERN? And 10 minutes?
Yeah, 10
minutes. 5-10 minutes from here. We're more than halfway now. And one thing that I'm streaming with my phone, and one thing that happens is that I check that. Oh, I don't have my phone with me. It's there, of course. Because I'm an idiot.
Check something.
Tell us if everything is fine with the sound. Okay, now we're in kind of a crowded place. We also bought the microphone, but we had some issues in connecting to the phone. I didn't know we needed an adapter and something like that. But yeah, I hope the sound is good. We were, abitate lontano dal CERN in periferia. No. Noi in realtà abbiamo...
It's not that far away. It's like 20 minutes.
20 minutes by tram.
By tram from the station. And from where I am, it's less than 40 minutes.
Yeah, exactly.
But it's only a tram, so
it's only one tram.
We are used to Rome and I'm used
bigger
to Rome,
cities.
so it's like very close. No, it's only me.
Now it's only you. I'm gonna be the guys off camera. No, I'm here. Gordon Freeman, yes, Gordon Freeman. Okay, so we also did this stream in order to test a bit the connection. Please tell us if there's any issue. We're streaming, of course, with a mobile SIM card, so there might be some interruptions, some small lags, but yeah.
So nice. We can maybe talk about the location. So it has a main entrance, which is in the Swiss side, and has there are three, if I correct, points that are on the French side of the border. And we will visit the Swiss one, which is the main one, and we will also go to one of these the French sides.
To the French side, yeah, we can give you a... Flavio, we're coming.
Oh.
130 si vola, stiamo arrivando.
E veniamo a pigliare.
Te veniamo a pigliare, merda.
Flavio, are you ready?
Tell us about the secret chamber of the CERN. Vismea fa poco
Dice il bagno di collateral.
So, ok, ciao a tutti, era un po' che non riuscivo a seguire una diretta, non c'è modo migliore di questo. Oh, ciao King.
Grande King.
Bentornato. Tell us about Black Mesa accident. We will talk about that. So, just we can give a small summary of the day, at least what's planned. Keep in mind that this is Twitch. So it means that basically it can change from any seconds to any seconds depending on how many people we have. So now we will arrive at CERN. We'll probably show you the outside, so the globe. There's like this big bowl of wood outside, which is kind of the symbol of CERN. Inside there's like an exhibition, which
kindly donated by the city of Geneva.
Yeah. And inside there is like an exhibition on particles, of course, but that is actually something that you can see all year long. It's always open. And so we will probably just go and get our press pass in order to get in the various exhibition a bit quicker, since we're not only, oh god guys, you're 288, now it's starting to get a bit hot in here. So we'll pass by the press pass in order to pass by to get the... There's a need of CERN, there's a need of Switzerland, says Luke McQueen, quoting the famous Bisbuch song. So yeah, we're heading there. Then after getting the passes, we will be going to the mechanical workshop where Flavio. Ciao Kenobisboch. Ciao. Thank you for the sub, Eren Marley. Thank you very much. And we pass by Flavio, where he's working. Actually, he's working as a volunteer today. And then after that, we will show you a bit. We will try to show you a bit like the common places at CERN, like library, cafeteria, like the main building, the one
where real people
stuff happens. Exactly, where real people happens. Also, Bisboch resubs for 25 times. Thank you very much. Thank you, Bisboch. And we will pass there, and then we will go and see Lina and the data center. So LINAC is the linear accelerator. That's basically the first part of the change, or better, it will be the injector, because right now it's still the old version, but they built a new version that will start to work in 2020, because now of course the big accelerator is shut down. So it's gonna be kind of exclusive, because we got an exclusive guide, luckily thanks to Flavio, that knows a lot of people, and people have to get out, and we have to get out of the way. That is what nice people do. And after that, we will look at the data center. So we will look at basically the grid infrastructures at CERN, all the huge computer farms that CERN needs in order to store and process the huge amount of data that is necessary for the experiment. So we'll visit that, or at least we'll try. Of course, again, it's Twitch, improvisation is there.
There's also a lot of people today at CERN, so we have
exactly,
to organize,
we have to see the
way that we don't lose so much time waiting for other people.
We also want to, in particular, thank CERN, because they gave us full support for this kind of streamings. We talked with their press office. We're super nice people. They were super excited about this thing happening. And so yeah, we will stop for a 1 hour pause, more or less around 4, because there will be the official CERN stream on YouTube and Facebook. But we hope that if this stream goes very well, they could consider bringing science on Twitch, because we firmly believe that Twitch is not only a place for video games, and one can do also other stuff. Yeah, it's pretty
science,
science. So you can can show Meran because Meran is it's pretty nice. It's a bit less. Okay. You can see this is the small town just outside CERN, where actually CERN is technically is. We cannot show you much more than this, but it's like a small country village just outside Geneva, and it's super nice. Super nice. Now the time is starting back. I'll show you a bit more about this because Twitch is also nice. CERN little village, and now in like at some point we will reach CERN. I think now it's 5 minutes or so. We showed you the whole thing. It's 20 minutes. We're live for 20 minutes. Yeah. So it's normal, more or less normal time. It's gonna be a little bit more crowded. But yeah, as you can, I won't show you the tram. I don't want to bother people.
Imagine a crowded
the tram is kind of super crowded.
There are two crazy people talking to a phone.
Talking to a phone. Also, you can see that the movie in French is called ça, which means this, which is super fun. Okay. So yeah, we will, as I was saying, we will stop. Yeah, let's switch on the other side. I don't want to bother people. We will stream until 4 in the morning from the Meran side, which is the Swiss, and then after, approximately from 5, when the CERN stream, the CERN official stream ends, they asked us to, of course, to stop during that time, so we could maybe make you move to their stream. So you can watch. So you can enjoy the official stream as well. We will move to the other area, which is the French area, which is Prevessin, where we will visit the control center, CERN control center, and Dune, which is the experiment, possibly NA62. I also have a friend with a very cool experiment. I don't want to tell you too much, but if we manage to go, it will be nice.
We'll show you several different experiments, not just the main one.
Yeah. So yeah, we're almost there. Grazie Fabio, thank you Fabio. Per gli amici italiani stiamo parlando in inglese perché sarà uno streaming misto. Cercheremo poi quando ci saranno le guide di switchare fra i due linguaggi, ma il linguaggio principale per gran parte dello stream. Poi magari su cose piccole e grandi cercheremo di parlare
vi leggiamo, se avete domande, chiarimenti facciamo in italiano e inglese.
The training is kind of noisy, of course, yeah, but it's almost over. This is the last stop before. Yeah. This is the terrible, we can show the terrible Indian restaurant that's here. It's terrible.
Remember, bad publicity is good.
Yeah, bad publicity is good. This restaurant is the only restaurant around Geneva, around CERN, and it's terrible. And yeah, that's it. Now we're almost there. We can see it. We probably get out from the other side. The train is on the table. Yeah, we get out on the other side. You can see that there's people. Now we'll switch to the front camera. Oh, look at this! You can already see. Yeah, you can already see all the stuff, and people normally here is not. There's not this kind of organization.
You're looking at the CERN.
This is basically the entrance. Yeah, we're showing you the main entrance. There's stuff interesting also on the other side. But you see, these gazebo normally are not there. And you see, it's blue because blue is the CERN color. You can see there's the shop. Oh, we can give a look at the shop actually. They have a lot of stuff. And now there is the tram that completely blocks our view, but we are here, so we can go and look how many people are there. There's a shitload of people. And you can see the globe. Okay, door open, we're here. Vitu! Hello guys, welcome to CERN. Vitu, stay there, so I have someone to talk to. Yeah, this is the globe
You're
we
very
were talking about. Yeah.
It's sunny in Geneva. It's not very.
It's very sunny. This is not normal. There's lots of people around. It's pretty interesting day. I've been
Two strange things: the sun and the people.
exactly the people. Normally is not that crowded here, and this, as we said, is the globe, which is like the main landscape of. It's kind of the symbol of CERN. It's like this huge ball of wood. It was like an architectural thing that was. Is this the beginning of Half-Life 3? The graphic looks great. Love you, man. Love you, man. That was very nice. And now we will head. We just wanted to show this, but now we will head to the, I think, reception area.
Ok, se mica sai dove.
Cosa?
Atlas, devi andare.
Atlas è qua, a destra. Of course, there are Italian asking for indication. But now we will cross, and we need to get the pass, and I don't know where it is. And Vittorini is stuck talking with people. V2, let's go. Let's go. Okay. So first thing. Kudos a ragazza sì, con la maglietta di Tetris. Sì, CERN is a nerdy place in any case. So we need to understand where.
Yeah, you have to understand first when to.
Let's ask the guy with the thing. Stream from CERN, real hardware. Sorry. Hi. Do you know how we can get our press pass? It's there. Checking. Okay.
Yeah, I'm not exactly sure.
Okay. Thanks. Okay, so this is like this is called Esplanade des Particules. So basically, it's like the square of particles.
Yeah.
It's literally called square of particle square.
Recently.
It's been renewed. In like
With the blue color.
1 year ago. Hi. Oh, it's on internet. Yeah, it's fine. It's called the gimbal. 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 Yeah, gimbal. You're live with 400 people watching you. Yeah. Say hello. Cheers. Piazza Bosone. I kind of scared her, but you know, it's kind of nice. So we're not showing our faces because press accreditation. Okay. Vittu, you go?
Io. Vado io.
Yeah,
Ma entriamo dentro, we can go.
I think we can go inside.
Yes.
Ah oui, bonjour.
Bello.
Est-ce que vous pouvez lever? Ah, ciao bella, ha fatto il Twitch.
Sì.
Puoi riprendere. Ciao,
You want to be on the Twitch stream? This is name, Daniele.
Come ti chiami?
Daniele.
Ok.
Divertitevi.
Grazie, ciao, grazie. Okay, so now we will switch to our ugly face. But hi. We will get inside CERN. Actually, we will get inside from the entrance B, which is like the classic main entrance, basically. and we're reaching for Flavio, and gonna get him. Someone screamed on our back. Yeah, it's Twitch. It's nice. Can we look? Let's give a look to the shop. Come on, just a quick look to the shop. There is a shop we cannot show. We cannot like leave without showing the CERN shop. So if you come here, you can buy like a lot of different T-shirts, a lot of different gadgets.
The celebrity T-shirt with the World Web.
Yeah, the shirt with the word.
We should have mentioned it.
Personally, I like a lot with the T-shirt with the Lagrangian.
Yeah, that's the classical. You see, every pieces that come here at CERN has the same shirt.
Exactly, everybody. But it's pretty cool.
You can recognize on the bus.
It's basically the formula that describes the world as we know it. So it's kind of cool to have it on your shirt. But now we stop.
You have it?
I have it. Yes.
No, I don't.
My former supervisor here at CERN, when I was working here with the first contract, gave it to me, but actually he got the female version. So it fits perfectly, but it's kind of,
Strange.
it's kind of strange how it's cut. At least for me. Not that it's strange, it's just not for me. It's kind of funny. So
It's not perfect for your body.
okay, we can show a bit also this is one of the other classical, views of CERN, the flags with all the actual states that participate to the CERN, let's say, how you call it? Council, yeah. With the CERN Council, and basically, the member state with all the member states. They used to be on this side. This was a big parking.
Yeah.
Actually, I used to park my car here, like here every time. But now luckily they changed it.
Yeah, there are nice exposition on what they do here. They're usually not here. You can see the Jura Mountains on the background itself.
Yeah, exactly. Yeah, we can show
They're
you.
very important.
They're very. Hello again. Ciao. So yeah, now we're heading towards the main entrance because Flavio won't be far from there. Oh, but I think it's the first time. This is a very nice view. On the back, you see there are the Jura Mountains. That's a mountain chain in France. Thank you for the resub serverless. It's called Jura. And curiosity is that Jurassic comes from the Jura Mountains because I think
They found the first.
I think the first fossils. And
it's
it's the mountains that you see on the back of CERN, which are actually like 10 minutes by car. You can reach the down part of it. There's a guy with a Commodore t-shirt, which is always a nice plus, and he didn't notice us, but that's okay. I wanted to put the Commodore t-shirt this morning, but then I said, no, it's fine, it's okay. And now we're heading for the entrance.
Oh,
This is the entrance B.
it's not the normal line.
Let us know because now we're heading towards a more expected. Some others know. And this is the queue for the entrance, I guess.
I can ask if there is a press.
Yeah, let's ask if there is a press thing. Hello? Hi, with press?
Tourist.
Here?
Ask the madam, yes.
Okay, thank you. Hello? Hi?
Yeah, so if you want to come in, you have to. No, this is press. They can enter here without any. No,
Okay.
they can enter.
Thank you very much. Thank you. Okay. And we're in. Okay, guys, welcome. No? Twitch. Say hello to Twitch. Woo! Oh, and here we have it. Twitch shirt with the same t-shirt. Somebody asked for a Colaterini. Colaterini is here.
Colaterini is destroyed.
Colaterini has been working since.
I was here at 7:20 a.m.
Perfect. But we can go and have a look at maybe what you were working and maybe have a short guide.
Yes.
What you are looking at. It's like one cascade of your emoticons on Twitch. So we can either do this or you can walk in front of me as you want.
What's the channel?
It's called Kenobisboch.
Yeah.
We're a retro gaming channel, but since we work here at CERN,
Okay.
why not do some streams as well about CERN? So yeah,
Not bad.
we can. I forgot to bring my things. Oh gosh,
Your business cards.
my business card. Yeah, you can follow us. We will be live for basically the whole day.
Twitch Inception.
Yeah,
okay. Thanks.
No problem.
Good day.
Thank you.
You too. Okay, so now we're heading towards our
We are passing Einstein's Road.
the first exhibition. Sorry, what?
We are at Einstein's Road.
Yeah, we can show.
The streets is.
The name of the streets inside CERN are all, famous scientists and mathematicians or engineers. Of course, this is
not yet there. I don't know
this
why.
is one of the main one, and of course it's called Route Einstein. This basically gets across the whole of CERN. Let's let's not forget that
We needed to mean.
CERN is a huge place. Like
That's why they borrowed the Geneva sightseeing trains.
this is the train that brings people around the whole area, because it's, if you want to cross it like from side to side, it's 30-35 minutes
Yeah.
walking.
And if you want to go to the other side, you have to take a car.
Yeah. So yeah.
There is the
This is the electronic building. I used to come here a lot when I was working on my electronics.
here.
Oh, we
This
can
is
show
where
that.
the first accelerator of CERN is. Now, of course, it's decommissioned and it's open for visits. There is a long queue. And yeah, this
You
is
can
called the
see
synchrocyclotron.
the big concrete structure on top of it, because it's meant as a shield for
Yes.
radiation, even if now it's not so radioactive
No,
anymore.
now it's not radioactive
Now
anymore.
it's not radioactive anymore,
Well,
but
the
so
visit
safe.
part is not radioactive anymore, and the accelerator has been used until the 90s. This is the longest living accelerator at CERN. They built it. They started building it the day after they signed basically the agreement. So in the 1954-55, and the thing has been operational until the early 90s. So
No, sure.
it's really a very successful machine.
Okay, so now we'll be heading towards the first
The motion
exhibition.
sickness? No.
The motion sickness. Yeah, tell us if there's so much. Vai da Bressanini. I know who the guy is, but I don't know how he looks like.
Who?
Bressanini.
That Bressanini.
That
is here?
Bressanini should be here.
No, I want to meet him.
Maybe we can try
I
that.
know
one.
it looks like how he looks like.
Okay.
But we should. So if we see Bressanini, definitely want to.
Okay. So what are we gonna see?
So,
I'll walk
okay.
in front of you,
Now
and you can explain.
Now we are going to the main mechanical workshop at CERN, which is a mechanical workshop.
Yeah.
And this is where we at CERN built very important parts of accelerators or detectors or vacuum systems. And of course, being this CERN, we have very precise requirements and very sophisticated machineries. We're going to see some of them. So it's split in two parts. On my right, we have the big size workshop. On the
Okay.
other side is the main workshop. Maybe we can start from the.
Let's start from here.
big
We
side,
should be able to get in more easily with the press pass, I guess.
No, there's not a.
There's no queue? Okay. Because, yeah, of course, it's CERN is particle physics, but there's a lot of engineering, of course, required in order to perform this kind of very complex.
And look who's here. Because of course now you will see how I know, like, not everybody, but
It's
Yes.
yes,
say
Letty.
hi to how many people?
450 people.
Welcome to CERN. Very nice environment. Especially the mechanical workshop. We have it in two parts. Did you show them the mechanical
No,
workshop?
we start.
Not yet. We're here. You're our first stop. You were our first stop.
Okay, so I'm very lucky.
Okay. Yeah, we explained just a bit. We show them around. We show them the Einstein Street. You know, it's
Nice.
the nice stuff.
We'll have tons of things to see today. Enjoy.
Okay.
Ciao guys.
Ciao, Letty.
So here in this room they have a metal 3D printer which works with basically they have a metallic powder and then a laser. The laser melts down the metal and then they put layers on layers on one on top of the other of metal until they create.
Okay.
icons.
Maybe we can show them. Yeah, this is the
So
poster
this is just the
explaining.
poster.
But yeah, you can see this machinery. You can see it from the screen, I guess.
Actually, probably it's better.
It's very, yeah, because there's an actual window. Yeah, the laser is melting the metal in order to construct a complex structure. Maybe we have some objects.
Yes.
It's a Metal Gear, and we have a Metal Gear there.
Do you have the book?
Yay.
So
Okay.
this is Romain, the expert of this machine.
Hi, Roman. Say hello to 540 people. 450, but it's the same.
So this is a titanium ball, 3D printed with that machine.
We can get outside a bit more.
And I want to show you something very cool about it.
It is titanium.
Titanium, yes.
No, don't break it! Don't break it! Oh, wait. Do it again. It bounces. Poor connection. Okay.
Really?
A bit. No, but sometimes we have some lag. It's okay. For now, it's kind of. We couldn't ask for any better. Do you have any cartridges for the railgun? They ask.
That's classified. Actually, this is not true. There is nothing classified at CERN.
How much does it cost, the bouncy ball? They ask.
I don't know.
But that is made with the printer.
Yes, it's made with that in the printer there.
Okay.
Which can print stainless steel or also other materials like titanium. They can also print niobium. It's a very nice bit of equipment.
Can we get a look inside? La palla pazza radioattiva.
So this is what I have been doing for the whole morning.
Yeah, because explaining. I think this is like the generic.
No, the thing is this. Here is this is the mechanical workshop. So of course, most of the people working here are exceptional mechanical engineers or technicians, but they don't know a lot about physics, particle physics in particular. They may know a lot about mechanics, of course. So I was here as a physicist in order to explain to people what is an
physics.
accelerator and the physics beyond it.
And also, I want to show you the huge. I don't know how it's called this in English, but this in Italian is a carro ponte, which is one of the coolest names. Crane something. This is a huge crane that can bring up to 20 tons. 20 tons of stuff, and of course it's used in order to move huge, pieces of hardware and metal. And now here you can see the various exhibition. I think those are radio cavities. Those are cavities.
Yes.
So basically, these you see these pieces of is that I think it's kind of a.
Those are cavities for radiation.
No, what's the material? It's copper. But basically, it's the part of the accelerator that are used to accelerate the actual particles.
But
So
we will have more on this later.
Yeah.
We are going to have a tour with an expert.
exactly. Okay, so we will explain that
In an accelerator.
to us a bit better.
This is basically the cable, the coaxial cable, which is actually a coaxial pipe, needed to bring high power RF signals
To
into
the actual
cavities,
thing.
for
So
example.
you normally you have your TV, and you have the antenna, and you have your coaxial cable. That is a coaxial cable, but that is CERN coaxial cable to bring the signal. Just to give an idea.
And then is the CNC. This is a CNC machine.
Sorry, it's a.
CNC machine. That over there on the top is the drill, and this thing rotates and moves on all the axis. This is not yet finished. They just received it like few weeks
And what do
ago.
they use for?
This is used to machine parts. So it's this big, and the advantage of having it so big is that they can, instead of disassembling, if you have, for example, a section of the accelerator, instead of disassembling it and then machine the individual part for repair, for example, they can put the full thing in here and then machine what they need.
Okay.
This is a good time-saving measurement for the mechanical workshop, which is always overwhelmed because there are many things to do.
Since I mean we gave a brief introduction to CERN during our tram visit, but now we have a lot more people. Do you mind giving a short introduction at CERN? What do we do? What do you do? Because I don't work here anymore. What is LHC and what is what kind of experiments are there even that are not connected to the actual accelerator?
So my name is Flavio Pisani, for those of you who don't know me, and I'm a PhD student. I'm a physicist, and I'm doing my PhD with the University of Bologna. Okay, and I work for one of the 4 big experiments on the LHC, which is the Large Hadron Collider. In particular, I work for the LHCb experiments. Okay. So, what is the LHC? The LHC is the largest and most powerful particle accelerator collider. So basically, we put protons inside. Protons are particles that are in nuclei of atoms. We accelerate them to very high energy, and then we smash them together. We smash them together. Yes. We smash them together, and then we see what happens afterwards. Okay? To see what happens afterwards, we have what we call detectors. So we build those big experiments around the machine, and we look at what happens. It's basically, as the sexy climber always says, Stefano,
Ciao,
sexy
Stefano.
climber Petrucci, that will probably join us later. Of course, it is like you have an orange and you want to see how it looks inside, but you cannot open the orange. So what you do instead is you throw the orange against the wall, and then you look at all the parts of the orange, how they spread around the wall, and you look. And you understand how the orange is made inside. This is what particle physics
It's basically
is.
when you were
In
a
an
kid.
orange shell.
When you were a kid, and you had two toys, and you wanted to see how they worked inside, so you smashed them one together on another, so you could see. Oh, so this works with gears. Oh, this works with the little, little metal rods and stuff like that. It's basically the same thing. I hope you hear. We had greetings from ATH Zurich. That's great. Crypto cartridge. Very nice name. Tipo il carnevale di Ivrea, ma costosissimo. And how here we have, maybe we have something to show. Yeah, there is. That is what we use to basically overclock our CPUs. No.
Yes, that's an overclocker rig. I don't know now what this is. We could ask.
I think it's in French. Mechanical strain. There's a lot of. Okay, that's fine. Okay, it's in French, so it's kind of a mess.
This one is in English.
Okay, that's great.
Okay, this one I know a bit.
Azoto liquido. These are these are super nice. These I did it once. The modes of the. Maybe we can ask him to show it.
This is important. This is a piece that they made for the open days, and it has all the main techniques that are used in the main workshop. So they made this to show for the open days what they can do and all the different techniques.
Okay. So in the meantime, there's 800 people. Okay, maybe it's showing off. This is super interesting. It's basically he's going. You can see that depending on the frequency, the salt that is salt on top of the speaker that is now vibrating is putting on. It's taking different shapes depending on the notes of the signal. ASMR, yeah, ASMR moment.
But of course, for certain applications.
Yeah. And also here, okay, I think they show how they model. I think they show. Ciao Yoshi! Ciao Yoshi! Ciao Yoshi! Aspetta, fate salutare. Ciao Yoshi! Ciao, bellissimo. Salva schermo ad alta energia, sì. Ok, we can go on. This is a cutter, like the other one. Is there anywhere we can... But this is live, it's on the back.
This is only doing the calibration. It's a calibration program, and you look how it goes around the ball without touching it, and it stays there. This is amazing.
It's basically used to cut, right?
Yes, it's a CNC machine.
Maybe you can see it.
Look, now this thing is huge. It moves super fast. It goes around the ball without touching it.
Look. I don't know. Maybe here, because there's a bit of a reflection from the out. But you can maybe see that it never touches the actual ball. So just to give an idea of how precise we can move robotical arm nowadays.
And this also needs a lot of power because it has to.
And this is the thing. And then this is the kind of kind of stuff that they can do.
Of course, they cannot run the machine with general public in the.
No, in the area. Okay. Let's go on. This is just the first exhibition, so this gives you an idea of how big.
And this is like small, the other one is bigger.
Yeah. This is materials and metrology.
Metrology and measurements.
Yeah, how they perform. Yeah, these are basically probes that they can use to push inside pipes to check. And this is pretty popular also in the mainstream world. Thank you, Beppongi, for the resub. And yeah, here there's a little bit of metrology, microscopes, and things like that. What's in here?
There's another CNC machine.
Hi. Can we? Yeah, we can show.
This is actually running or not?
No, I don't think it is.
It's changing the bit. Look how cool this thing is. It changes the bit.
Ah, it changes the bit of the thing. So this is another. Oh no, it's moving. It's moving. Tornio. It's a tornio. How is it called tornio?
No,
How is
tornio is the one that turns around.
This is basically just it's a scalpel. I guess it's a drill. No, now it has a drill. Oh gosh,
It mills away.
it's moving. It's moving. It's alive. It's alive. It's a machine they use to make, of course, super precise mechanical parts. It's drilling. I think it's fake drilling now because, of course, it is. It's. Oh no, it's so fast I cannot see it moving. No, it's working. It's working.
Because this one is fully closed, so they can run it with people inside.
Yeah, makes sense. And now it's changing the bit.
And all of this, of course, it's programmed with a computer and it's automatized, so the operator does not have to manually do those things.
Okay, let's go. Vito, do you have some water, maybe?
Yes,
Or maybe
I
you
have
can
some
get
water.
the Coke I have on the back. Hi. Dammi una cochina. Ma questi macchinari sono lì al CERN perché si fanno i pezzi in totale indipendenza? Sì.
Some parts are designed and engineered at CERN, some other are outsourced to other companies. It depends on how many we need, no? Because of course, CERN is not an industry, so we cannot make things on an industrial scale.
Yeah, of course.
But maybe we can find some. For example, this is the design office. So if you have a customer that are coming for a workshop and they want to design something, they discuss this with the team, and they may modify the design to make it doable or not. They decide if they want to make it here or if they want to outsource it, depending on how many pieces they need, which machinery they need.
Also, you can show from the outside how that machine looks like. It looks like a big Luna Park for grown-ups.
Yeah, that's. It's what it is.
It is.
They are grown-ups meshing stuff and.
These machines are normally here. They haven't been moved here for the.
No.
Okay, wanna go in front? I would love.
It's an interesting question.
Does the switch French border somehow? Oh, I lost it. Wait, sorry. Which somehow impacts certain functionality border? No. The border is not noticeable in day-to-day since let's say, especially if you work at CERN, they do not. I mean, they see that you are from CERN. You show the badge, and they're kind of more, let's say, less. And also, there's an entrance from the other side of CERN. I don't think we will see it today. It's like the entrance on the other side, from the French side. If you want to skip the border, but it's only for certain people.
Yes.
Okay, so this is a collimator.
This is a collimator. So basically, whenever we have a beam of particles, you have the core of the beam which goes alongside with the optimal trajectory and stays there, and then we have what we call the halo of the beam, which are particles that are a bit farther away and they are going out of the optimal magnetic well, let's say, that we have in the machine. It's not called magnetic well, okay? So this thing basically moves, okay? Physically moves and goes closer to the beam. Then
a beam, we're talking about a beam of particle that goes
the beam
inside.
of particle goes in the middle, let's say. This thing moves, and then it takes the particles in the outer part, and because there is the material, then they will be basically destroyed in the material, and those are removed. And this is very good for the stability of the machine, for the accelerating machine, so that we don't risk to, for example, lose the beam because it's unstable, or in the LHC case, the machine is a superconductive machine, so every particle that goes away from the beam goes into the magnets, it hits the magnet up, and this may cause what we call magnet quenching, which is basically when the superconductor is too hot and is not a superconductor
Loses
anymore.
its because basically in order to curve the particle inside the particle accelerator, we use these huge magnets made of superconductive material, and sometimes they lose their superconductive status, and that is called quenching,
yes.
and that is very dangerous.
And we have to dump the beam.
Extremely dangerous, and you have to shut it off, basically shut off the machine. Here's
Dangerous, of course, for the machine.
Dangerous for
It's
the machine, not for the
dangerous.
people.
It's not going to explode.
It's not because it's dangerous for the machine. Okay, we can get outside. What is this?
It's an experiment which is at 0.8. Okay.
Okay. We can maybe cross and go towards the main building.
Yes. We can also go to the other side of the mechanical
Let's.
workshop.
Okay, we can give a look to the other side of the mechanical workshop. We're back outside. I mean, this was the huge hangar we were in that we just showed you.
Actually, only part of it is the mechanical workshop, but the biggest part of this huge building, which goes on and on, is a test beam area. So basically, we have particle beams that are extracted from the accelerators and are then here used for tests, for example. So if before designing a new experiment and putting it on the LHC, first we want to test if it works. So we test it here, which is much cheaper than just put it on the LHC and then we see does it work.
Okay, makes sense.
And there is also a project which is called Beamline for Schools, which is a project with school students and they tell them how to like build a beamline and how to work on it.
Thank you, everyone. Thank you, Larigan, for the resub. Thank you, Ruho Games. Sorry, I cannot really see the screen. It's very sunny. But thank you very much for supporting us. And now we're moving to the other mechanical workshop.
Yeah, this is the main building.
This is it's where that it was more a warehouse, let's say.
No,
but this
come
no,
on. That
not
is
a warehouse. It's an hangar.
No,
it's
it's the big equipment.
big equipment, mechanical engineering.
This is the general mechanical.
Sorry. No, that's fine. And from here we can. There will be time. There will be time. Also, the bus is continuously like. It's too light. Yeah, exactly. They need a weight because it's continuously moving. And here we have another mechanical workshop. What? Maybe here we can explain a bit. We can use this nice panel to explain a bit about the accelerators. Guys, go.
I go, you go. So, I did this for the old morning. So this is the LHC, okay? The 27-kilometer ring. Now, this is a proton collider, as I said before, so we need to put protons inside and to accelerate them. First of all, we need to get the protons. And as you know, protons are sold in all the gas stations. You just go there with your empty proton tank, fill it up,
and it will work.
No, wait, this was gasoline. Sorry, my mistake. So where do we get the protons from? Okay, protons are actually extremely abundant in nature. In particular, the hydrogen atom is basically one proton and one electron. So if we strip off the electron, what we are left with is just the proton. Okay, and this is how we do. So at the beginning we have here a tank.
We will visit this.
This
later.
we will visit. We have what we call a source.
LINAC 4.
Yeah. So the LINAC 4 now is a bit different than what it used to be, but more or less we get the hydrogen, we remove the electron, and we get the protons. Then okay, we just inject the protons into the LHC. No, wait, this won't work because this machine is designed for very high speed, and it won't work very high energy. It won't work with particles that are not high energy.
It's like gears of a car.
Yeah. It's
You
like,
cannot go directly into fifth gear.
Yeah, you have to go out.
Yeah.
It's like if you try to drive your Formula 1 at 30 kilometers per hour in the traffic. Okay? I own a Formula 1, I always drive it. Yes. Okay, this is the linear accelerator. Okay? So how do we accelerate particles? So to accelerate particles, we need an electrical field. Okay? We have a charged particle. The particle with a positive charge, for example, will go towards the negative side, let's say, of the electric field and away from the positive side of the electric field. Okay? If we put two electrodes with the electric field in between, we can accelerate the particle once. If we put many one after the other and we alternate the field, we can then always push the particles in the right direction, and we can have a linear accelerator, basically. Okay? And this is what is done here. The LINAC 4, we will visit it later. Then, after the linear accelerators, okay, now the linear accelerator accelerates H minus ions. So what I said is not really true. What they do is instead of removing the electron, they put another one. Okay? Then they strip them down and they obtain protons. At the end, you accelerate and you get protons. Now, the protons are then put in this small ring, which is called booster. This is not an accelerator, it's just an accumulation ring, which means there is a ring that accumulates particles in, as the name suggests. So, I told you we accelerate particles, but now we have to bend them because this is a curved trajectory. How we do this? Well, we can use magnets, okay? So, if we take a magnet, we can bend the particles around the trajectory we want. Okay? So this is basically a long sequence of magnets that are collecting those particles. Then when we have enough particles built at CERN, so circular accelerator, it has been built in the late 50s, sorry.
And it's still working.
It's still working. It's
Ciao
still,
Enrico. Ciao
it's
Enrico.
still, ciao Enrico. It's still a crucial part of the LHC. Okay? Without the PS, the LHC doesn't work now. It's 600 meters, so it's relatively small, and it accelerates the particles almost at the speed of light.
Already.
Okay? So, as you may or may not know, the speed of light is the maximum speed that you can achieve, and if you have a mass, you cannot even reach it, because to reach speed of light, for a massive particle, you need infinite amount of energy. Why? Well, because now I said, okay, they are almost at speed of light, so then the speed won't increase anymore. But then we continue accelerating them. What happens? What happens is that we increase the energy. So in particular, if we take into account the momentum, which is in a classical way the mass times the velocity, so the speed. If the speed stays constant and the momentum goes up, this means that the mass goes up. So what happens from this point onwards is that the particles are not getting faster, they're getting fatter. Okay?
Just like us.
Hopefully not.
After 20.
So here we're already at speed of light, as I say. They are ejected from the machine, and then we can have, you can see how CERN is the LHC, but it's not only the LHC. There's many more experiments than this. For example, here you can see with the protons, we can produce antiprotons, and then we can use them in the antimatter decelerator to produce anti-hydrogen atoms.
Which is the coolest name for an experiment ever.
Antimatter factory is the name of the complex now. So we can produce anti-hydrogen, and we can study it, okay? Then we can also, for example, get the protons, produce neutrons, and study neutrons, which are very interesting as well. Neutrons have a bit of a problem, they're neutral, so you cannot either accelerate them or bend them. So we get them the way we get them, and that's it. Nothing much you can do about it. Now, the main use, of course, of this is injecting particles into the LHC. So what we do is we inject them into the SPS. SPS is a 7-kilometer ring. It has been built in the late 70s, and there were 2 Nobel Prizes awarded for this ring.
One is Italian.
One is Italian, Carlo Rubbia, for the discovery of the W and Z boson, which at the time were like the Higgs boson in 2012, more or less, for importance of the discovery. And one to Van der Meer Van der Meer was
An engineer. It was an accelerator engineer, I think.
Whatever, it doesn't matter.
I think it was.
Is the one who made this accelerator possible.
There's a crypto cartridge that says that you're way better than his physics professor at ETH.
Thank you.
No problem.
Okay, so here, then we accelerate the particles even more, and now we reach an energy which is around, it's a bit less, but let's round it up to 400 GeV, giga electron volt. What is this? It's a weird unit of measurements that we physicists use. Now, I don't want you to understand what it is, but what I care is I want to give you some a way to compare it, okay? So, Einstein says that the mass and the energy are more or less the same. So we can measure the mass and the energy with the same unit of measurements, let's say.
We pick the energy.
We pick the energy. So the mass in energy unit of measurements of a proton is 1 GeV, okay? So
Giga
one
electron
of
volt.
the thing that I said before. Now here we are at around 400. This means that the protons are 400 times fatter than what they used to be. This is only the mass, they don't increase their size, okay? It's only the mass.
And after
They're
this,
protons after Christmas.
And that's exactly.
After
After this, they go into the LHC, this 27-kilometer ring, which has 4. This is a collider. A collider means that it has 2 beams that are circulating in opposite directions. One like this and one like this. And then they collide. Okay?
like this, and then they collide in these 4
Yes.
points.
Atlas, CMS, Alice.
Alice, and LHCb, which is the one where Flavio
best
works.
one.
And after that, basically, these detectors, these experiments are huge cameras. Basically.
Yes.
They're like
They're
huge particle
sophisticated cameras.
detectors that detect the various particles, can reconstruct how the collision is happening.
And this is the thing that you use to look at the wall after you throw the orange. Basically.
Exactly. It's how you look at the wall. No,
Now,
just to
another
give an idea.
important thing. Those two experiments are general purpose experiment, which means that they look for everything, nothing in particular. Why do we have two? Why we don't have only one? No. Building an accelerator is expensive, but also building an experiment is expensive. Why we don't have only one? No, in principle they look for the same things.
Because you want to check if the results are okay.
Exactly.
So if you have only one experiment,
How can you check?
how can you check? You have no reference.
Yeah. You want to avoid something like, okay, look, we found the Higgs boson, cool. You call Stockholm and you say, look, we found the Higgs boson. Then they call Professor Higgs. You say, Professor Higgs, we're very glad to award you with the Nobel Prize. And then after 3 years you find out that, oops, there was a mistake and now there's no Higgs boson. What do? You call Professor Higgs and you ask for the Nobel Prize back. You don't want to do those things, no? That's why we have two experiments. So that if they both see the same things, then we can be reasonably sure that it is real and is not an artifact of a bad design, for example. Of course, the two experiments use different technologies and different teams, and we do analysis in different ways to provide maximum independence. Okay?
Maybe we can move, I think,
Yes.
a bit, since we bored enough our
I can shut up.
list. No, it's fine. I think it was a great introduction. Thank you very much, guys. Thank you very much, Flavio, for the introduction. But yeah, I guess it was a nice thing. Can you get your prize back, please, lol? Okay. Yeah, they're still machine parts. You see, they are able to perform this kind of very.
This is a Van der Meer horn magnet, for example.
So they got the Nobel Prize for this stuff as well. And this is a huge bong. No, it's it's a huge exhaust pipe for a car, for a very big car.
This is very nice. You can see all the contribution.
Here you can see all the.
So this table here is for components that are outsourced to other companies. As I was saying before, CERN is not an industry, so we cannot just make all of our pieces. Maybe we make the prototypes, but then for mass production, usually we outsource them. CERN is a collaboration of many states, so we outsource, if possible, to states that are members of CERN. Okay?
And you can see, I
you can
gave
see those
an
member
overview
states.
of all the things that are around. Yeah, here there's more machinery to build.
This is a tornium.
This is a tornio, I think. Yeah.
No, actually no.
No, it's more of a drill.
it
No, it moves. No. We're not very familiar with mechanical things. we were working in electronics, so mechanical stuff is not our strong point.
I know a bit because I had a tour yesterday. You see? Those are pieces of accelerators.
It's showing something. I don't know if it's visible, but it's building again something automatically using this huge machine. Here there are the screens. I think they did a much better job this time with the CERN. I've been here the last time; it wasn't this cool. They improved a lot. I'm super happy about this. Whoa! Look at this.
I think this one is the case. Can move to the other side.
Go the other side?
There is a very cool welding machine.
È un forno per le pizze. Ad ogni modo, switchiamo. Okay, we'll switch a bit in Italian just to give an idea to maybe all the people that not very familiar with English. Ok, stiamo visitando al CERN per gli Open Days. Ora siamo. Quindi è una manifestazione che avviene ogni 5 anni, quindi è abbastanza rara. e sostanzialmente stiamo visitando le varie mostre che ci sono in giro. Ora siamo proprio all'interno del CERN e stiamo visitando la Mechanical Workshop, quindi sostanzialmente l'officina meccanica, che sostanzialmente mostra come...
Qui potete saldare in realtà virtuale.
Ah, saldate. Ricordate che con la maschera da saldatore nessuno può vedervi piangere. Infatti, vedi che è molto bello. Yeah! Quindi ora stiamo visitando l'officina meccanica, ci sono tutti sostanzialmente gli strumenti e le varie tecniche che vengono utilizzate per costruire i vari tipi di oggetti meccanici di metallo e altri materiali che servono per realizzare gli esperimenti qui al CERN, ma anche tutta l'infrastruttura che fa girare l'acceleratore. Vabbè, ad esempio queste enormi pipe che servono, sono cavità, videocrab cavity. Senti, vogliamo andare verso il main building, abbiamo ancora un po' di tempo.
Facciamo, devo prendere la macchina fighissima per fare la saldatura col fascio di elettroni.
La saldatura col fascio di elettroni. Andiamo.
Yeah, there is a machine for electron beam welding. So basically this machine is a kind of a small particle accelerator. It creates a beam of electrons which then is used to weld the material. And this is one of the finest machines for welding, and it produces amazingly clean
Welds, I think.
which are extremely important if you want to put them things into a vacuum, because you don't want to...
Sì, è un macchinario per saldare con un fascio di elettroni. Dov'è? Questo qui? Minchia, quel simbolo radioattivo. Questa è una roba che sembra uscita da Prey, proprio, comunque. It's like a Prey machine. Cannot be shown, I guess. The inside. I don't know if it's visible, but I think they will kill me if I go further. Okay, guys, let's go out and let's...
Those are beam pipes. The beam goes inside those.
This is the part that really contains the beam inside the thing. Let's go to the main building. Because we have a bit more time. We have an appointment around 3 to watch Linak, but it's like a 10-15 minutes walk. So we still have some time. Ok, ora stiamo in realtà andando verso... Ci sposteremo da questa zona appunto dell'officina meccanica per andare verso gli edifici principali del CERN, quelli cioè collegati alla vita di tutti i giorni, tra cui la mensa, e diamo un'occhiata un po' alla mensa, alla biblioteca e magari qualcos'altro, cioè, se riusciamo a dare un'occhiata al 40, che forse è l'edificio che architettonicamente è un po' più carino, perché comunque il CERN, per carità, ha tanti tipi, diciamo dal punto di vista architettonico non è esattamente un capolavoro, è una serie di uffici, sì, pochi architetti, invece quello comunque è uno spazio molto nuovo, è molto bello. So, as I was saying, in Italian we're now moving towards, let's say, the general purpose area of CERN, basically like a cafeteria, library, because we want to show you also a bit of the normal life here, because how many people work at CERN every day? Like 10,000 people or something like that? 7,000 people?
I think it's around 8,000.
8,000
people
people.
to calculate because there are, I think, around 5,000 people that are CERN employees, but then there are many people that are from collaborating institutes. Okay, so they have a CERN badge.
We can pass by here.
We can pass in.
Let's pass by here. Let's pass inside. Yeah, we can show some of the... I like this. I like showing you because now there's a lot of... Oh, sorry. There's a lot of the exhibition around, but it's nice to show you also the normal offices.
Wow.
Like,
Empty offices.
empty offices, but CERN is also this, because this is where most of people like work. Here is the area where the physicists actually do their analysis, if I'm not wrong, right?
This
is the
is
32.
mostly the Enrico.
Enrico works here, I think, for example. Blue hoodie.
This is more the software, core software development team. But of course, offices are a bit mess around. So.
We're just taking the shortcuts.
Yes.
We're just taking a bit.
Oh, we can go and see the web thing.
The web black. Okay, yeah, let's.
Pass by my office. Don't look at it because it's super messy.
We can look at Flavio's office as well. It's super nice. Of course, I mean you might not know, but basically the internet as we know it was invented at CERN.
The web.
The web. I mean the internet as we know it is the web. The web was invented at
I
CERN.
always hate people confusing internet and the web.
I know, you're right. But still,
This is the most important thing of CERN.
the Nespresso machine. Sì, è importante la macchinetta del caffè, che tanti dolori addusse.
So this is the LHCb main building, let's say.
Mm-hmm.
So most of the offices here around are LHCb. And at the end of the corridor there is also my office.
Yeah, this is a more normal office, as you can see.
Dun, dun, dun.
It's a bit Half-Life, a bit Doom, without the demons, or maybe the demons are just inside us.
But in those normal offices, Tim Berners-Lee,
Yeah.
9,
Sir Tim Berners-Lee.
13, oh well, it was not Sir at the time.
At the time, no, but now
It
it
was not
is.
Sir at the time. So, well, that's my office. Let's just pass by. It's so messy.
Let's. I can show you where Flavio works somewhere here. There's also Super Mario on the back.
Guess which is my desk?
Which is the shitty messy one with around a lot of boxes around. Ovviamente la. Grazie Cyber Rage per la sub. Or thank you Cyber Rage for the sub. So you can see that Flavio's desk is obviously the messy one. I mean, obviously. And now we're heading towards the main area, the main building of CERN. Hello. We see the plaque. Okay, we will see the plaque where basically the web was invented.
Because it may look like a normal corridor, but being this CERN.
Where the web was born, dove è nato il web. Questa è una placca commemorativa del 2004 che ricorda appunto. Puoi accendere la lucetta? No. Sei sfondata? Sei scassata la lucetta? Do you want to know how many people are connected right now?
No, thanks.
No, you don't want to know. Okay.
You want to know, man?
So this is no, you don't want to know, man. 1,200 people, guys.
Whoa.
Hello, my God.
Hello.
We're so humbled by all of this. Hello, if you don't see us, it's us. We're three physicists basically, and we're going around CERN during the open days. Thank you very much to CERN for all the support they gave us for this. And now we were giving a look. Oh, look at that! Oh, we have the first host of the day, Enrico. Ciao, Enrico. Which many of you might remember because he's a hell. he's a hell of a player. He's a hell of a player on Super Nintendo because we're mainly a retro gaming channel. So yeah, this is. I just wanted to show you this is the commemorative to show you the plaque that they put here that remembers where the web was started in this area. Even if it's main office, it's the IT. It's in IT, I think. His main office was in IT.
The office was here.
Are you sure? Because I heard different stories. Enrico, where are you working? Tell us a bit more.
You just passed by
your office.
You just passed by my office. That's how I tracked you down. I was just visiting the open days myself. Please.
You can also wait there. Yeah, just pick up something.
So it's just around. You just passed me in front of my office. It's one of these super old.
We'll get in the.
So as this year it was the 30th anniversary of CERN, and they made a very special event with Sir Tim Berners-Lee in person. So I had the chance of hearing what he was saying. You can clearly tell he's a very brilliant person. It was very difficult for me to understand his accent, though.
Yeah, I guess it's super.
But you could clearly see that what he was saying was beyond.
He's working on the next web, right?
Yes.
That's what he.
Thank you, Methods, for the sub. Okay, so now we will be finally heading towards, let's say, the. Sorry, I pressed the wrong button. Someone noticed the RTX on your floor.
Those are only for working reasons. Actually, yes.
Actually, yes. Actually, yes. Okay.
The boxes are empty, though. Huh?
Thank you.
The cars are already where they should be.
And this is the main building of CERN. This is the 500. Is it the 500? Yes,
Yes.
the 500.
Well, it's divided in several parts, but yeah, let's say it's the 500.
How's the connection? Is that fine? It seems we're not having any issues. Di nuovo, I'll switch in Italian for a few seconds just because, we try to bounce a bit the two languages. We're mainly an Italian community and retro gaming community, and we're here at CERN just because we happen to be or have been physicists here at CERN and we're visiting during the open days. So, questo è il building principale del CERN. sostanzialmente. Ciao Surgi, c'è Surgo, mitico Surgo. È il building principale del CERN, quindi qui è dove viene c'è la vita di tutti i giorni, c'è la banca e qui ci sono anche delle ci sono delle exhibition anche qui. Facciamo vedere la biblioteca che a me piace tantissimo.
Però devo andare indietro.
Vabbè dai, è sopra qui, tra l'altro facciamo anche le scale. Qual era? Qua c'è ancora il countdown alla fine del mondo? No? There was a countdown that was counting the days to...
No, the seconds.
The seconds
Until the expansion of the
expansion of the sun turning into a red giant. So this is the main building. You'll see, this is like the fancy area.
Yeah, like
The council
over there
chambers.
there's the council chamber where the council meets.
Exactly.
And this is the main auditorium.
This is the main auditorium. Hello, hi.
The DG office is on the last floor of this building.
Of course, the DG means Director General, which at the moment we're very proud of it. It's
Yeah.
Italian.
Yes.
And it's a woman. And
she's
that is
also
extremely
very good.
important. And she's an awesome physicist. And she's an
very
awesome
good
listener.
director general.
And everybody loves her. And so yeah, we're heading towards the library because it's nice to see also these parts because of course this is a place of engineering and everything, but it's also a place of study. And I studied a lot in here.
Really?
Can we get inside with the camera? Yeah? Me too, shut up. Yeah. No? Yeah. Okay. We'll be more silent now, of course, but we want to show you this. No, people talk. It's fine.
The cool thing about this place is that it's open 24/7.
Yes.
Yeah.
365 days per
Exactly.
year.
This is always open.
It doesn't matter when your deadline is, how badly late you are for your paper or whatever. You can just spend as much time you want.
And if you need to read a book, if you want to take it, you can take it, of course, but you have to go to the desk. But if you just want to read it here, you can go wherever you want.
Yeah, you can go. I studied all my exams here. I still remember where the electronic section is because I studied so many things. Ciao Surgo. Yeah, of course there is Fermi, which of course it's Italian pride here. And I think here there is the electronic section somewhere. I still remember, yeah, okay. They changed it a bit. Yeah, it's a pretty nice place to study here.
Yeah, look, you can have now the
You
nice
have
view.
a nice view and there's lots of books on everything, basically.
Everything on everything.
It's like if you look at the sections, they're completely different from your typical library sections because it's not like science fiction versus drama. It's more like quantum theory, general relativity, software development, like large scale data science. It's
Quantum fields, electronics, mechanical stuff. Topology.
philosophy of science.
Philosophy of science. Yeah, it's kind of specialistic. Also, there's a nice bookshop. So basically, you can get your book here. And also, the book manager is a very nice Italian person that I always met when I was coming at CERN for work. And now we're heading towards, I think, the cafeteria and things. Hello, thanks again. So here, yeah, there's a bridge. That's where we were before. This is the press office. Let's pay them homage. Thank you very much for all your support. Grazie mille al press office del CERN per il supporto di oggi, perché non ce l'avremmo fatta senza di loro. This wouldn't have been possible without them. So it seemed fair to show where they work.
Would like to thank the social media managers as well. For
Loic,
the
I
support.
think, and I hope it's how it's pronounced, but
Loic.
thank you, Loic. I don't, Loic?
That's French.
Ah, makes sense. So, merci, Loic. That's super cool. So, yeah, we're heading back to the main area, and we'll show the cafeteria. It's time for coffee. Yeah. Quindi ora stiamo andando nella mensa.
Here is terrible.
Here is there. Stiamo andando in mensa comunque in ogni caso. Ma qui c'era anche lo stand di radioprotezione, che se no passo a salutare i miei ex colleghi. In the meantime, we're like 1,500 people, which is kind of a record for our channel, guys. We're not expressing how excited we are just because we are so excited about it. And we try not to think about it. There's the little shop that's inside CERN, and it's for souvenirs and cigarettes and stuff like that. Oh, Vieri! Ciao Vieri. It happens, there's 100... 1500 persone ti stanno guardando in questo. Ciao Vieri.
Ciao, mi stanno guardando?
Sì, certo che ti stanno
Colgo
guardando.
l'occasione per dire basta a questi getti d'aria potentissimi, che se ti lavi la faccia mi spiego che ci metti la faccia giù.
Puoi provare?
Come devo fare? Io non lo
No,
so.
vabbè.
Quindi
Vuoi venirti?
mettiamola,
Stiamo
per
facendo
favore.
un giro.
No, sono super di fretta e sto andando via.
Ok.
Quindi alla prossima.
Ciao Vieri. Ciao. So yeah, that's kudos for... They say compliment for the... Dicono complimenti per la maglietta. È uno dei 1500. Uno dei 1500. So this is the caffetteria.
Of course, now it's very busy, but every day is very busy. Maybe not this late, but
Yeah, this is...
actually during normal hours, in working days, is way busier than this.
No, it's way busier. Yeah, it's kind of okay. It's kind of reasonable. Ste. So, as you might see, we know a lot of people around. Ciao, Ste. Come va?
Everything good.
Everything good? Hi.
Okay, bye bye.
There's... Where are you working today?
Electric stand.
Where... You don't seem very stoked about it.
I will go soon. Let's go.
Have a nice day. So yeah, that's where every day all the physicists and scientists and literally everyone
Everybody at CERN.
works.
Visitors.
Even, yeah, they eat. The cafeteria is also it's okay. It's I mean, we're Italian, so we tend to be extremely. We're Italian, so
For Italian standards, it's not that good.
tend to be for Swiss standard it's pretty okay. They're just showing a bit where we are, and we can show even the new cool area to it, which is nicknamed the IKEA because yeah, that's it's kind of nice to eat here. It's a bit crowded normally. Now it's kind of okay, but we can go outside
It's okay because it's too.
because there's a party outside.
You can go outside.
Yeah, let's go. Can we get? We can get off from here. Yeah.
I think this is the music club.
This is the music club because there's lots of clubs at CERN. I mean, if you work here or even if you don't work here but work in the surrounding area,
You can join the clubs.
you can join the various clubs. For example, there's the photo club. I was part of the committee of the photo club.
There's the ski club.
Ski
there's the
club,
diving
electronic club, frisbee club. There's even a frisbee
retro
club.
gaming club.
Yeah.
Basically, you name it, there's a club at CERN.
There's a retro gaming club.
I think so. No?
There's a retro electronics club. And we'll show you some of the music. Come on, let's go. Oh, ciao, Alessandro. So yeah, there's lots of stuff. Let's give a look here. Yeah, you see this is the nice outside. Questa è la parte esterna del CERN. This is a piece of the pipe. Basically, it's like a reconstruction of how the pipe looks
This is the
under.
cryostat, so the thing that
Yeah.
makes it cool. And if you go into the LHC tunnel, you will see 27 kilometers of this, more or less.
Yeah. Is there any chance for someone who wants to work at CERN by a physicist? Yes, of course. Just apply. There's lots of different career opportunities. Just go on the CERN website. That's how we managed to arrive here. I just went on the website and I asked for, I did my application and they took me.
We should go.
We should go. We don't. Let's show the 40. It's okay.
We
Right.
have to run.
No, we don't have to run. We can go. We can cut. We can cut a bit. We know many shortcuts around.
Cuts.
We know many shortcuts around. Yeah, here it is more of a feed area.
Train.
Or maybe we can take the train.
But I don't know where it goes.
But here we wanted to show you this is the biggest and not biggest technically, but certainly one of the newest and more architectonically interesting building at CERN. This is the 40.
Sociologically interesting.
Sociologically interesting. Why?
But that's on CERN, come on.
So you see there are 2 towers, 4 towers. Well,
It's like Lord of the Rings.
one tower is from the CMS experiment. Well, one side of the building actually, it's 4 towers as Flavio said, right? So half the building is for the CMS experiment, the other half is for the Atlas experiment.
And they are a bit in competition with
These
each other.
are the 2 biggest detectors. They do the exact same job. They look at the exact the same physics, you know. And the first experiment that finds something interesting is basically the one that will have all the citations for the papers that are in the glory, right? So they look at each other from the balconies, right? Stare at each other and hope that they're ahead just by those 2 weeks of research, so they can publish first.
Revolving door and voila. Okay, this is I wanted to show you this because this is pretty nice. A pretty nice building, and I always liked it a lot. So there's like this huge dome. This is
And this is 1-to-1.
This is 1-to-1. I don't know if you can see, but that is a floor. So you see that space between 2 things. That is a floor. So it's huge. It's kind of huge.
It's about 15 meters high.
Yeah.
Atlas
CMS.
is bigger, that's why there is no Atlas there, because they couldn't fit 1-to-1.
Yeah. Questo è, I'll switch to Italian just for our Italian friends. Questo è uno dei building più nuovi, cioè uno degli edifici più nuovi qui del CERN, dove lavorano tanti fisici fra CMS ed Atlas. E no, that is CMS, quello è CMS, questo qui che abbiamo mostrato qui. E qui ci sono i 2 esperimenti, diciamo quelli là un po' più grandi, quelli in competizione, che hanno i loro scienziati sostanzialmente che lavorano qui. Prendo un po' pur connection, no, si è risolto. E niente, facciamo un giro. I think there was like the retro gaming it's here. Yeah, let's show it. There is also a retro gaming exhibition, and since we're like a retro gaming channel, why not see the retro gaming area? It's upstairs. Let's go. We have a bit of a poor connect.
Attaccate al wifi.
Che vuoi?
Proprio quando usciamo dalla perdi, Cosa serve?
Non ti vedo.
È un attimo.
Ci siamo?
3 now. Like now.
You have scheduled a new visit here?
No.
Well, we just passed by.
Yeah, we wanted to give a look, but we completely lost connection inside here, so we're heading outside because we're not streaming right now. Yeah, maybe. Yeah. Okay. No. Now we got it back. Now it's working. I think it was the. Sorry, guys. Oh, thank you for the sub, Gesta. Grazie mille per i sub. We're having some issues with the connection because we were inside. Yeah, there was a. Of course, the retro gaming area is the only area of CERN where you don't get the internet connection. But there was a very nice selection. Yeah, there was a very nice selection of retro hardware. Where
CERN is stop everywhere. Stop for retro gaming as well.
Retro gaming here? Yeah, that's pretty cool. I'm sorry, we'll try to show you that later also. Now, we'll do one of the classical activities that we do at CERN. So walking from one building from the other, that are pretty far from one another. And
So it's walking time.
can we get some water?
Yes, I have water.
Thank you.
A lot of stuff.
Era l'ufficio di Peter, ciao Bibi! C'è pure Ari!
Grandi! Si è svegliata.
No, abbiamo avuto qualche problema di connessione prima. Tra l'altro ora vedo 0 spettatori, quindi spero che non siete andati via tutti insieme.
Dai, meno Ari.
Chissà, abbiamo perso il counter e in fondo forse non è male. Ok. Vai, divertiti un po'. Oh,
It's better like this. So you can see Antonio.
Stay hydrated, friends. Stay hydrated. This thing is super cool. Where did you get it?
Ariana bought it.
Oh,
Thanks, Ari.
Very nice. That was very nice.
Yeah.
Okay, guys, I'll head back. Have a good visit.
You head back. No, come with us.
I'll walk with you.
Linak far. Let's go.
Come on.
Well, yeah, let's do this.
Dai, tell me that you have to walk.
I was trying to not walk 2 kilometers.
You know,
under the
retro
sun.
gamers are lazy.
I was going back to the retro gaming.
He was going.
You catch me. They had Pong.
Wanted to take the car and.
We'll try that again later.
Yeah. It would be very nice.
They have retro Wi-Fi in the retro gaming.
Exactly, yeah, retro Wi-Fi. It's kind of difficult
32
to stream
kilobytes.
with retro Wi-Fi.
I don't know if you mentioned like how CERN doesn't look as fancy as you might expect.
It's way more fancy.
It's way more fancy.
No, it looks. It doesn't look as fancy as it's depicted in every movie.
It's
That's
a lot
the
of
point.
it's a lot of barracks and,
Yeah.
and old buildings, but I think that's the beauty of it because it's beautiful on the inside. It's what's
Like
on
all the
inside.
physicists.
People, it's
Yeah,
it's
like
not
because-
about the journey.
We don't waste money on useless crap like fancy buildings.
Exactly.
We only invest money into useful physics.
The money is into hardware, brains, right, and whatever is
And parties, of
100
course.
meters.
You can't forget the parties.
No, we're kidding.
We need to buy all the protons.
Yeah.
Yeah.
Expensive protons.
As I said before, you have to go every time to the gas station to fill your proton tank.
And by the way, historical thing, I used to work there for on that building over there for 3 years. And before that, I worked in a place where we will visit later. So you'll see that.
I think it's better if we go straight.
It's better if we go straight.
Yeah.
Take the shortcut.
You promised some shortcuts, so
The shortcut
Now do
is
you have-
the
now you
same
have to
length
deliver.
as the non-shortcut, but okay.
But it's a short, it's cooler. You got to admit
Indeed, it's cooler.
Sorry.
You want some water? I mean, you want Daniele's water, maybe?
You can. Come on, water is water. Yeah, I don't know.
So now we're going to. I mean, you can see that CERN is huge. It's basically a city. It's like a whole city. I don't know the actual extension, but believe me, it's freaking huge. In order to walk from, let's say, one extreme to the other, at least of this, let's say, how do you call it? This area, this site, because there are two main sites at CERN, and this site, if you want to walk from one extreme to the other, it's like 30-40 minutes. something
Yeah.
like that.
Yes.
It's kind of long.
There's 2 restaurants, 3 hostels.
Yeah.
Three restaurants.
a
There's
bank.
another one in France.
Yeah.
No, on
here.
this side, and then
this
another
side.
restaurant on the other side. This is the Swiss side, so in Switzerland, and then there is the French side in France with the third restaurant. It's freaking huge. I think 2,000 to 3,000 people are here at any time.
Way more. It's like 5,000 and only the CERN employees plus with the users. I think it's more like 8,000.
I was thinking just the Miran side.
Wow, in Prevesan there are not many of people, no?
Poi
So, yeah.
andato giù
Sì,
con
sì, ma ci sto, ci sto.
It's a small town.
And now we're walking towards our first, let's say, appointment that we
Yes.
have. And we're gonna visit Clinic 4.
Sorry,
which is
I
actually,
am about to be.
the new
Yes.
first part of the accelerator chain of LHC that's gonna start taking data in 2020.
Let me contact.
I'll just switch to Italian for our Italian
Child
friends.
forgets.
Siamo all'esterno ovviamente del CERN, come ho detto il CERN è enorme per camminare da parte a parte almeno solo di questo sito, perché sono due main siti, due siti principali. Questo sito che è quello là un po', in realtà pure l'altro è grandicello, ci vogliono una quarantina di minuti attraversarlo da parte a parte e ora stiamo trasferendo nella zona dove c'è l'INEC 4, che è la nostra prima visita, in cui visiteremo l'acceleratore lineare che servirà da iniettore, quindi da catena di accensione dell'upgrade del grande acceleratore del MIC di LHC, che entrerà in funzione dal 2020, quindi lo vediamo un po' in anteprima. 2020, no? 21? And now we're passing by one of the shortcuts, as we say, even if it's not technically a shortcut, but there's many things like this, many like small alleys between
Yeah.
buildings. Because again, this is a city. It's basically like a whole city, and it's the fortress of science.
I also would like to
The
point
fortress
out-
of science is the
I
coolest
also
thing.
want to point out something. See if we have a good example. So, okay, here. This building is number 171. That building.
No, fai così.
Vai tu.
Ti conviene fare doppio clic che si resetta e poi puoi fare inquadrare.
So this
These are-
building is 171. That building is 256. That building over there is 162. So as you can tell,
building 2008.
and behind us is building
2008 for no reason.
So as you can tell, the numbers are basically random. So you can never assume that building, I don't know, 30 is close to building 31.
No.
So if you don't know
It's
the
on
number,
the opposite
you
side.
have to check on the CERN map. And once I almost missed a meeting because it was in building 30, which is on the other side of CERN, and I thought it was close to building 31, which is literally the next building from mine, which is building 2. You know? And yeah, when I realized that it was 30 minutes walking, I was almost like missing the meeting.
You see those gas tanks? So those do not contain hydrogen. But if you take one as big as one of those with hydrogen in it, that can supply the LHC hydrogen collider for pretty much forever. That's so it's the material, like the protons that run inside the accelerator. Those are the cheapest part of the whole thing.
Yeah, because as I said before, we have the packets of protons, so the bunches are 10 to the 11 particles, and in 1 gram of hydrogen you have 10 to the 36, more or less. So we have many particles in 1 tank of hydrogen.
Yes, it's super hot today anyway. I'm dying. Stay hydrated. Now we will show you something interesting about the outside of CERN, because CERN is kind of in the countryside. So sometimes you walk around and you see this beautiful scenery, and this is all what's it called? Vineyards. Vineyards? Is that vineyards? Vineyards.
Whatever.
And they're just beside, and we call this the Vineyard Street. Even if it's not technically called like that, it's probably some scientist. This guy is Becquerel, but this is the side street. And this is the other extreme of CERN.
This is half.
The other extreme in one direction.
These are all wine fields, and once a year they actually do the Cave Ouvert, so open wine cellars day, where you can just go buy a glass and then you go from wine vendor
producers
to wine vendor, directly to the source, and you can do wine tasting and buy it.
That is a Tesla making music. You can hear the Tesla coil making music. This is where Matteo is, I think. Let's show the after Linak, if we have some time. This is super interesting. It's one of my I have a very close friend that's working on that experiment, and he showed me in the past days, and it's super nice. Now we got like an appointment for Linak 4, and we're almost there. Yeah. Oh god, it's great! It sounds great. It sounds like a synth, but it's actually a Tesla coil. So it's like you know what a Tesla coil is? It's like basically one of the simplest form of particle acceleration, one could say. Can you hear the music?
Can you hear us?
Video game music. I love Switzerland. To all scientists, come here. Great place to work and live. Oh, crypto cartridge. So thank you very much. Yeah, I think it's a pretty nice spot where to live. You can see the force of nature, and in general, it's a very good balance between work and everything. So here, there's a huge queue, but I think we have an appointment for this. Hi. Sorry? In English will be better. All right?
Rendezvous avec Vittorio Bencini.
Ah, sta facendo guida.
Ok, ci deve venire a portare noi, si chiama. Vabbè,
Riusciamo a sentirlo?
Guarda, sta per scendere in questo momento, quindi
no.
Ok,
come?
perfetto.
Datemi un nome.
Penso che era il suo. Sì. Grazie per thank you for the resub New Pego, thank you. Grazie mille New Pego. Va bene, allora ora organizziamo un attimo per entrare, dobbiamo trovare la nostra guida che giustamente è un po' perso nel nulla, no, ma sta lì, lo vedo. C'è Francescone, vabbè, ovviamente. It's CERN, so we know a lot of people around, we worked here. Conosciamo un po' di gente perché comunque ci abbiamo lavorato e in realtà Flavio ancora ci lavora. Beh amici, che ve ne pare per il momento? Va bene? Anche lui. Anche lui
It's very busy today.
È molto
I did not imagine so many people would come here for these open days. Pretty much all the visits.
So if you're interested, you have 5 years to plan for the next.
Exactly, 5 years to plan for the next one. There's people from all over the world. Yeah, there's a little bit of queue, un po' di
There are
coda.
queues for all activities, so it's very very good that you got press passes.
Yeah, it's very very good. Let's see if we can make that work, because in this case we had like a friend that's working here as a guide, so we asked him to kind of reserve a slot for this stuff to visit Linac 4. We see if we manage to get in, and in the meantime we can enjoy a bit the scenery. See here, see, there's even plane arriving, because the airport is pretty near.
That's the Mont Blanc.
And that's the Mont Blanc on the
Monte
way
Bianco.
back. The Monte Bianco è lì dietro in fondo.
From the other side.
From the other side. Kind of
For the Italian viewers.
Very positive. You have the plane landing and.
Yeah, it's a pretty nice view. Notizie da Vittorio. 10 minutes? Let's go and have a look downstairs. Ok. Ok, perfetto. Ok, so while Flavio. Nel frattempo Flavio parla un attimo con la nostra cosa. Nel frattempo possiamo andare a vedere giù la musica, anche se credo. A salutare Matteo. Perfect sense. You can see there's.
Ciao.
Dicono che la parete fa un effetto muore meraviglioso, mi sa quella lì nella cosa.
Anche questi tetti con tutto il muschio.
E ovviamente io vado addosso alle persone.
Schivare noi.
Okay, we're heading towards, I think, this is the electric, the power converter slab. I have so basically this is the people that work in supplying the power for the machine. The right one. Okay, thank you very much. We can give a quick look, because you know there's exhibitions everywhere. So this is how they manage to supply energy. Matteo, c'è Matteo? Let's see if Matteo is there. Matteo!
Streaming live.
Live, 1,500 people looking at you in this moment. Can you give an overview of what you're doing
So
here?
welcome to the best stand of Open Days.
You're working in it.
No, we are here at the electrical power converters stand at the Open Days 2019. We have many activities. Did you miss the Tesla Coil show?
We heard it from above.
Amazing.
It was amazing. What's the next one?
Next one, so you have to come when there is the actor as well. So because we have two types of shows. One, just making music. The second one is music plus an actor touching the electric.
Because you can see there's like a...
Yeah, that is
let's go
Tesla
near,
Coil.
let's go near, because it's not really visible.
Wait, I turn it on. I turn it on, Antonio, for you. Only
Really?
For you. But go in the middle. No, we like you, Antonio, so don't do it. So this is a Tesla coil, and basically this is a 2M Tesla coil, which stands for 2 meters. So the electric arc is 2 meters. The output voltage is 500,000 volts, and the current going through the aid is about 50 milliamps.
50 milliamps. Okay. So it's not that much. Yeah, it's very little. It's a lot of tension. That's super interesting.
Yeah, absolutely.
So this is what was playing before, right?
Yeah, exactly. And then we have many activities, but the coolest one, because I mean, if I'm not wrong, this is also a video game.
Really?
No, I mean, which is the channel you are transmitting?
It's our retro gaming channel,
retro
of course.
So this is not retro gaming, but it's video gaming. And this is super cool. This is developed by the software guys in our group.
That's a very nice monitor. By the way. Oh, you have.
And this is my colleague Raul.
Oh, ciao Raul.
He's a software engineer, and maybe you can describe this video game.
Come here. So basically the idea that we want to do is focus on power converters. Okay, so we have two types of power converters, dipoles and quadrupoles.
Okay.
So dipoles basically we use them to bend the beam, so they stay within the tunnel. Quadrupoles we use them to focus the beam. Okay? So basically here the idea is you have the Xbox control.
Okay. No, I don't want there's kids. I don't want to.
Okay. So the kids got the controller basically with the left thingy, the knob.
Yeah.
You control the position of the beam.
Okay.
With the right, basically you focus the focus. And the idea basically here we make it like a game. There has to be like fun. It's not for real.
Yeah, sure. It's just to give an idea.
But basically what
You
you're
can
doing, you're converting power converters. You're controlling power converters.
In order to keep the particles on
the particles
on the
track,
beam.
yeah, and you have to avoid basically these obstacles. Well, actually, in the beam there are real obstacles, something like that. Okay, what we call collimators. And basically you have to run for a minute. So he managed, and now there are collisions.
Perfect. So he managed. So well done. Well done. Well done.
That's pretty cool. There you go. So basically we developed this from scratch, including the maquette.
But it shows things. It shows. No.
Otherwise you would see like LEDs.
Okay, that would be cool.
Okay, but we're trying to fix it. But
so apart from like video games and huge, massive
Well, Antonio,
Tesla coils,
I know you very
what
well.
do you do?
I know that you like sport and biking.
Oh my God, no.
Every day you bike at work, you bike at market, you bike at... So if you want, Antonio, now it's time for you to do some sport.
No.
So this is, Antonio, maybe this first time you see this, it's a bike.
It's a bike, yeah, I know.
Bike.
What's this? How it works?
It's a bike, you have to do some strange stuff.
but it's electric, no?
It's electric, of course it's electric. No. So basically it's a standard bike.
It's power converters, no?
It's power converter, but actually the bike is used to generate energy. So basically, with I hope it works because there are too many people using it. We didn't do a live test. So yeah, and so the idea is we charge a capacitor and then we discharge it through this electromagnet, and inside we have a piece of metal which
Sparks.
goes up and ping.
It makes the symbol go.
Exactly.
Can we do it?
Exactly.
Maybe we can see. I'll try not
Absolutely,
to.
yeah.
There's a kid, so it's better if I don't. But I can. Yeah, like this. Maybe we can show.
Yeah.
Italiani che parlano tra loro in inglese. Sì, in effetti sì. Welcome to CERN. He's doing it. Yeah. So it's 50 kilojoules and then going. Go, buddy. There's only 1,500 people looking at you.
20 seconds warming up and now 15
Oh, now he's going. Now he's really. You picked the electronic music, I think, Matteo. I can hear your. I can feel your touch here. Because Matteo is a Renaissance man. He's a kind of a bit of a Renaissance man. He's a scientist, and that's the symbol. He's a scientist. He's a musician. He's a producer. He's a DJ, and he's also like he actually worked on an FPGA.
Let's kiss.
Can you know? But we can do this because he actually worked on a very cool thing, which is your
synthesizer. Yes.
Your synthesizer made on an FPGA.
Made on an FPGA that we have here, by the way.
You have it here.
Yes,
Can you show us the thing?
And there is Giorgio, maybe also explain.
But we
Let's
can.
Let's have a look.
Everybody calls him Giorgio. Giorgione. Here we are.
You can steal the description from him.
This you made?
Yeah, so I made a synthesizer.
The synthesizer is. Ciao Giorgione.
Oh, guarda chi sei.
Hi, how's it going?
1500 ascoltatori.
1500 persone are looking at you in this moment. Can you please show us maybe around when you finished with the what
Yes,
else?
you see they're playing around, and actually, what Matteo had the idea of trying is, as you know, in our group we produce the equipment which is needed to drive currents in the magnets in the accelerators. In a very similar way to what happens when you plug a synthesizer to a speaker. You drive a current through a speaker's magnetic coil to produce sound. So the idea was, what would happen, how would it sound like if we plugged our equipment to speakers rather than a dipole or an electromagnet. And of course we loaded 4 programs which resemble somehow the way.
Poor connection. Let us see. Tell us if we're back. Control F5 if you have any issues. We're back, finally. Okay, we're back. Thank you very much. I'm looking for Flavio. He should be around We'll be back at the Sint area, I think, if we manage to. You know where Flavio is?
Yes. Flavio.
Sorry. Oh, Vittorio! Wait.
Hello, man. Okay. Say hi to 1,500 people.
1,500. No, you don't want to know how many are we. We are 3,400 now.
Vittorio, guys, now as you see there is a huge queue. I will just bring you inside. I will give a brief explanation about what you're going to see. And then hopefully we can win the tunnel in not waiting too much, okay?
Great, thank you. Thank you very much. Thank you very much.
But we pass from the side so we avoid to create panic.
You're still out spotting, doing the hot spotting, Flavio.
What? Yes.
Sei ancora col plot spot. Guys! V2! Dobbiamo andare.
Victor is doing some public relations for the channel. Some French person
wanted to know
a business card.
Sorry. Okay, we managed to get in. Oh, Francesco! Ciao.
Ciao a tutti.
Ciao. Non c'è male. Flow control to Major Tom, they say on the back. Yeah, no, he's a great guy. He's a very great guy.
Best technician I know.
This is the best technician at CERN. Yeah, people confirm that.
Okay, guys. Want to come here? We can start. Actually, just we can go down briefly.
Okay, that's great.
We start from here. As you can see, pretty cool stuff. I guess my colleagues already gave an introduction about the CERN accelerator complex, how it works.
Yeah, about that.
Here we are speaking about LINAC 4. LINAC 4 is going to be the new linear accelerator that is going to provide the protons to the to the full accelerator complex. Before it was LINAC 2. LINAC 2 was just a proton accelerator. Actually, here we have a small difference. What we are accelerating are H- ions, meaning a proton with 2 electrons. Just the important thing to say is that in LINAC 4 we produce H-, accelerate them up to the energy of 160 MeV. That equals more or less 50% of the speed of light. And at this point we strip the electrons from the proton and we go on accelerator chain up to the final LHC energy for the collisions. So what you can see here is where everything starts. This is an H- source. Basically, in an H- source there is a plasma chamber. So from a simple hydrogen bottle you inject the gas into the plasma chamber. The plasma is generated. What a plasma is a very particular state of matter in which it's kind of a cloud of protons and electrons interacting one with the other, but without bounding. At a certain point, what you do is generating through chemical interaction on this surface. You generate this proton with 2 electrons, and now they are charged particles, and you can extract them using an electric field. What provides this electric field is this tiny electrode in front of it that allow to extract the particles. Exactly, extract the particles and bring it to the accelerator, into the LINAC. How the plasma is actually generated? By 2 means. The first one is a so-called RF antenna, which provide an electric field to the plasma. And on top of it, you have a magnetic field that basically confine the electrons and the protons inside the space of the...
And what are we watching here?
This is exactly what you see in the picture, so from the back.
Okay, so it's exactly that central part.
Exactly that central part. Around is completely covered, so in there you have the solenoid magnet, inside the RF antenna and the plasma chamber. If we come on the other side, we can see the tiny hole is actually where the beam is extracted.
Perfect.
So here everything starts, and this cone that you see is the extraction electrode.
Okay.
So here
you
there
can
is an
clearly
electric
see.
field. Exactly, you can see this gap. There, an electric field is formed that allows to extract the ion beam and bring it to the stage afterward.
Perfect.
The stage afterward, I will give an introduction about how a linear accelerator works. I will do it here because we don't have so much time in the tunnel. So I think it's better if we start here and then we go downstairs and I will show you the structures. Basically, general particle accelerator physics, a magnetic field bends the particle, the trajectory of a particle, an electric field can accelerate it, so gives energy to a particle. The way in which an RF particle accelerator works, an RF cavity works, is basically that if I want to accelerate a particle in this direction, I induce an electric field that oscillates between negative and positive on the direction of propagation of the beam in itself. But as you can clearly imagine, if I accelerate when the particle is traveling in this direction, when the field changes direction, I would decelerate the particle. So what I do, there is a small trick that is used. Basically, if the particle is traveling, it interacts with the positive field that accelerates it, and then we introduce a small cylindrical tube that shields the electric field when it is negative.
Okay.
This mechanism allows the particle to feel just the positive field while it travels to the accelerator, and so it gains energy, and the purpose of the accelerator in itself is achieved.
People were asking how big is that hole on the thing, more or less?
It's 6.5 millimeters diameter, so it's very, very small.
Okay.
And now we are studying different bore diameters because it affects a lot the property of the extracted beam, of course, and so we are trying to optimize this in order to maximize the extracted current. Okay. Because the main purpose, of course, is always to have the maximum amount of particles in, let's say, the smallest possible dimension with the smallest possible divergence.
Makes sense.
In order to increase the number of collisions. Okay. So, just another small thing, we said that magnetic fields bend the particles. So the second important thing of a linear accelerator are the magnets that are used to transversally focus the beam. It means a beam exits the source having a divergence, so spreading around. What you want to do is to keep it, to prevent it to impinge on the tube, on the cavity. So in order to keep it, you use a magnetic field that
to focus basically the beam. In order to avoid that makes damage. Yeah.
Exactly, to damage, but also to lose particles that are very useful for in terms of luminosity and collisions.
For the experiment.
They're precious. So, this is the basics about acceleration. Now we are going downstairs. I will give you an helmet. We go downstairs,
that's great!
And then I will show the major points of the accelerator and their characteristics.
Okay. Guys, we're going downstairs, and I hope that we still have some connection downstairs. I don't know how it's going to be.
Guys, first of all,
what is this?
A nice hairnet.
Whoa, hairnet.
The world today.
We have to put an hairnet.
Let me do this one.
And an helmet is coming.
Yeah, perfect. This is very small.
Big guy, for everyone. Sorry, this was very small for quite big. Fino a inquadrare Flavio, che bello.
Voilà. Vai. Grazie. You need to leave the bag.
You have to leave the bags, yes. Okay, leave it like here, maybe behind the chair, so then you can bring them out.
Okay. So now we're going down to the tunnels. It's the Selena
it is like just
guys.
It's not as deep as
no, it's not as deep as the LHC.
It's just like 12 meters. But
still is under.
We are going to take the stairs.
Oh, okay.
I should be always in the okay, guys. I hope it's good enough.
How's the connection? It's a bit. Now it's good. It's a bit. I'm sorry for the connection. Get the Wi-Fi password. No, but we have the Wi-Fi password. It's just that, of course, it's kind of crowded today, and. Posso? Grazie. Grazie, Francesco.
Yes. Okay, if you want to wait here for a second or...
we can try... We can try with...
Here you should have Wi-Fi, I guess.
You you
There
have?
is, let me check.
I don't have any connection, but we can try with the.
There is Wi-Fi. Switch to the
CERN and stop
just my phone that didn't switch to
Okay, now we should be better. Now we're back online. We're back online.
downstairs. Before it was to the upstairs network, and of course.
Correct. So now we're heading down the stairs. Thank you, Vittorio, again for your patience and. Wow. Style.
Okay, guys, now it's kind of full of people, but
Okay.
It still works there.
Whoa.
okay, guys.
No, it works. Kind of works.
Here, you see, if you go there and put your hand a bit on the side, you can actually see the full.
This is the full linear accelerator that basically ignites the whole chain of the up to LHC. It's like the ignition key of the biggest machine in the world, and it's here, and you can see how long it is. Can you see it clearly now? I mean, we kind of reset the stream hoping that it would be better. It seems it's very good. It's going very good, the connection, so it's great. People are like, whoa, in the
Start
chat.
from there because I think it's interesting. One has to start from the very beginning, as we did like upstairs. Ta-da. This is the actual ion source, the one that is working. I mean, we have seen a model, exactly, we have seen a model upstairs. Here, the main difference is that you see it's completely covered around, so you cannot really see the plasma chamber. Important fact, this bench is usually at 45 kilowatts, so it's in tension. Everything is closed, you cannot enter.
Of course, otherwise you're dead.
It's a problem.
It's the last time you do now.
And yeah, for basically that's it. I mean, you can have a look at this. Just some details. You have two vacuum pumps.
Those on
that
the
are used to pump away the air both in the source and in the first part of the rabbit, the low energy transport line that we're going to describe now. Here there is the lab with the power supplies.
yeah, of course.
And there, if you I think it's interesting, there you can see actually the hydrogen bottles.
Ah, yeah, that is. I always love that. So you can see those steps. You can see from the outside. Because this is something I always love. It was open here. So basically, all the particles that then CERN LHC uses and that smashes one against another, they all start from these little tanks. Okay, so this is the actual particles that get injected into the accelerator, and it all starts here. So basically, this is the fuel. We could call the fuel of the accelerator.
Just to give some numbers, the amount of particles per bunch is structured, then we will see what a bunch is, but it's a package of particles, is 1/10 to the 9.
Yeah.
So which is a kind of a big number, but imagine that this bottle can last for a full run.
For a full run, forever. Just one
need to change.
bottle of gas, it's enough. It's enough fuel. We'll briefly switch to Italian, maybe just to give a few few explanation, a very quick explanation of everything, like in Italian.
In italiano? Allora
Sì, sul Linac 4. No,
ok,
basta anche
sul
solo
Linac
sul
4.
Linac.
Ok, solo in italiano fondamentalmente il 4 è un acceleratore che accelera ioni H-, ovvero un protone con due elettroni legati, e abbiamo visto sopra e adesso la sorgente. Fondamentalmente l'Inac 4 accelera le particelle da 0, energia 0, e state la sorgente al circa l'1% della velocità della luce e le porta fino al 50% della velocità della luce. È lungo 70 metri e adesso vedremo che lungo l'acceleratore ci sono diversi tipi di struttura che diciamo cambiano a seconda di quelle che sono in funzione dell'energia, e sono più efficienti o accelerano meglio a seconda di quelle che sono le esigenze. E quindi vedremo differenti tipi di cavità man mano che avanziamo lungo la linea.
Chiedono dalla chat l'attuale bombola da quanto tempo è in uso.
Questa non è nuova, perché comunque questa macchina è nuova, considera?
Ma una bombola più o meno quanto dura?
Dura, ha detto, l'intero run.
Cioè è infinita praticamente, comunque il numero di particelle che servono dentro una macchina, che si usano per una NASA, sono talmente basse che dentro una bombola pressurizzata non c'è un problema. E poi costa poco, fortunatamente.
Beh, idrogeno. Okay, we'll switch back to English. That was just to give an idea to our Italian.
Else here, guys, we see this is called the low energy beam transport line. or transfer. I do not remember. But basically, the purpose of the line is clear.
Speak
As
towards
name-
the phone because the microphone is there.
Yes, basically the purpose of this line, of this small piece of accelerator, is basically to transport the particles from the source to this object, which is called radio frequency quadrupole, and it is the first radio frequency accelerating structure. So we explained when we before how the principle of RF acceleration works. Up to this point, there is no RF acceleration, it's just electrostatic, so an electric field. These two beautiful purple stuff are solenoids, which are used to focus the beam, and so to put it in the proper way into the RFQ, while these elements are steering magnets that allow to correct for trajectory error at the output of the source. So if there is an initial angle or the beam is off center, you can correct for it
Perfect.
and go in the right way into the RFQ. The RFQ is an amazing machine that was invented in the 80s actually, and it's not a common structure because it doesn't only accelerate particles, but it also focuses them. So it has a mix of fields that allow to focus the particles transversally, accelerate them, and bunch them. We said before, a bunch is a package of particles. So you start from the source in a continuous flux of particles. In this structure, you change this time shape, let's say, and you start to bunch the particles all together. The same time structure, modified in a lot of ways, but then it's somehow the same kind of structure that is going to arrive to the LFC. Modified, but still the same. All the properties of the beam are defined here. So the beam quality is basically defined in this very point.
I'll just do some machine porn if you do not mind. So going going towards just showing how complex all this. Look how long it is.
It is 70 meters.
70 meters.
Here you see something that is called, it's the same as a limit, but it's just like, it doesn't accelerate, it's meant only to transport the beam to the following stage. Okay. And here we arrive at so-called drift tube Linac, is the exact principle that we explained before. You can see these things, these structures. From these structures you have a rod, a copper rod, that hold the copper drift tube. Okay, that actually shield the particles when the field is negative. A cool thing that you can see is that the more we go along the accelerator, the bigger the distance between the tubes are.
You can clearly, you can clearly see this. Look how close are here. They are here. They're basically like one after the other, touching. And if you look here, they're much further apart.
If we move that direction, we will see how big the distance.
Yeah, and now we're walking and doing like a walk by of the whole thing, and it's like I hope the connection works, but no, it seems it's going. But you see how far apart they are now. Because of course, the more the particle accelerates, the faster it goes. So you need more space between basically the various kicks. Yeah,
with the field
to be synchronous with the
positive part. And just a few details, these are cooling tubes, if someone may ask, and this is what is called a tuner. A tuner is a copper rod that you can insert or extract into a cavity. That you can insert or extract into a cavity to correct for frequency error in the resonant frequency. So it's a cool thing.
That's super. It looks super nice. But all this machinery, it's something that you do in house. Or it's something that is produced outside? It's a bit of a mix.
The design is done completely in-house, the mechanical design, the production of most of the pieces, but not all of them, because most of the time for any machine you have collaborations with the university, institutes or industry. And I cannot answer specifically, I don't know which parts, but usually it's always like
a mix of the two.
Yeah. Here is like how it looks like the inside of a DTL. So here you have these famous drift tubes. In the middle, in these gaps, the particle is accelerated due to the positive field. Here is when the field becomes negative. So here is shielded.
These rods here are the
Yes.
rods that are attached to this little head on the top of the thing.
Exactly.
So also inside it will look with these various cavities that are closer and further apart depending on the thing.
There is another detail that each one of the drift tubes actually holds a magnet.
Ah, okay.
Because we were speaking before about the focusing needed. Here you need a lot of focusing, let's say at low energy. So you need to have a magnet for each structure, which is an engineering complication that not negligible.
Not negligible.
That's the reason I said this just as an introduction, because when the energy becomes high enough, you basically don't need to focus so frequently, okay?
Sure.
So you switch to a different kind of accelerated structures where the magnets, the quadrupole magnets, are just in between the tabs.
Ah, okay. Here
Once
they are.
every 70 centimeters, meter, it depends. And here, also the acceleration, it follows the same principle, just as we said, it is optimized for this range of energy where we are, okay? So it consumes less power, and basically the acceleration is better and more efficient.
They ask what's the temperature inside the tubes at what...
They are absolutely not superconducting, so
Okay.
they are room temperature.
Ah, they're
The
room
only
temperature.
thing, they are cooled. The reason because the cavities are cooled is to avoid the formation of the structure, because if you heat copper, they are made of copper, if you heat the copper, you change the shape, the geometrical shape that affect the resonance of the electric field into the cavity. And
Makes
this is
sense.
something that we don't want, of course.
Okay.
And so we keep the temperature of the cavities through the cooling water.
No, poi batteria ancora un altro poco, ma attacco il cavetto quando torno
Ci sono
sopra.
un sacco di oggetti di vario genere, ma penso sono dettagli. Quello è un collettore, per esempio,
Ok.
di nuovo permette di correggere l'orbita centrale della particella.
And yeah, it just goes on and on.
It just goes on and on. Unfortunately, we have to stop here.
Yeah,
you
no,
can see it's
I can show it. I can show
two
it.
things that we can show at this point. First, that there the kind of structure changes again. You see that there's
Yeah,
a change
sure.
of color.
Yeah.
Again, same principle. You change type of structure because it's to have a more efficient acceleration at this higher energy. And in the end, you see the green stuff.
On the
These are concrete blocks, and it's the dump.
Okay.
Because we are in a commissioning phase of the machine, so we don't want to bring it into the circular accelerators. So all the beam that we produce is basically dumped.
It's
on the last
a
point.
huge block of concrete and lead where particles go to
And
die.
the main reason because we cannot pass this point. Let's say.
Because it can be a bit of an issue.
Radioactive and,
It's a bit
so on.
radioactive.
So that's it. And from this point, I guess. Okay. Another thing, when you get to the end, there is a bend.
Okay.
And then there is a transfer line. The transfer line has the purpose of transporting the beam at the final energy from here to the PS booster.
Okay.
first circular-
The first,
exactly.
the second gear of LHC,
Exactly.
basically.
Where the electrons are stripped, we have protons again, and we are done. And ciao,
Perfect.
basically.
Whoops, sorry.
And,
Yeah, it looks
okay.
super nice, especially like I'm actually from home. I think you're seeing it better than us because this is a very good perspective from here to see how long it is and how complex and how this repetitive section actually change after
Those are
a while.
waveguides, right? Ah, this is super cool. Yes, these are waveguides. If after here you go to visit the surface of the inner force, they explain the structures, and you see the clystones. The klystone is basically what provides the power that they inject, that is the RF power that is injected into the cavities, and this signal has to be somehow transported, and you do it through this amazing stuff here, these waveguides, that then goes down, and they are there. If you want to see here, for instance, here are coupled to the cavity.
Ah, okay.
So from here, woof, you put the power in, and you have the electric field resonating into the cavity.
They are asking from the chat what if you know how much power does it take to let's say
Honestly, no, I don't want to give a wrong answer, so honestly, no. But it's an information that you can find in principle easily.
Okay.
But sorry, I don't know how much power it is.
It's fine. It's okay.
Well, this is as big the conductors must be for the power, right?
It doesn't depend on the power. It's a waveguide, so it depends on the frequency and I mean, it's not empty just on the power. It's empty inside, completely empty, and it's just in order to transport a wave at a certain frequency, an electromagnetic wave at a certain frequency, you need a certain geometry. The dimensions of the geometry changes just with the frequency. Basically, it doesn't depend. What changes the power affects the thickness of the walls of the waveguide. Same again about the formations and this kind of stuff. So here the dimension is given by the frequency.
Then I guess with the skin effect, probably you don't need to make it much more thicker.
No, it's just
Most of the
it's,
current
the thickness is due to you don't want to
heat it up.
To heat it up, exactly.
Yeah.
So the thickness is just
It's just like heat.
Exactly, because actually if you are anticipating kilowatts, megawatts, because the order is always like this kind. Of course, you are heating up a lot, so you need to have like thick walls.
Okay. And you'll need to move all of this in place of the old linear accelerator.
No, it goes here. It stays here.
There is not a picture here, but there is Linac 2. You can actually visit it now because
It's right
below.
next.
Yeah, it's like there is Linac 2, Linac 4. They build it like a side, and that's the reason because the transfer line is kind of complicated. Basically, you have to turn right, make a vertical step, and then you connect to the previous transfer line.
Okay, makes sense.
So
It's kind of a mess.
Okay. In place already.
In parallel, because actually they built it, but they stopped, Linac 2 stopped operations in December. Yeah, after 40 years.
Okay, now we're heading back. I'm gonna.
Yes, unless you have any questions, but if you may want to.
No, it's fine. It's okay. Yeah, I'll just show a view of the machine.
Just one.
Yeah.
Because you've seen the RFQ. Actually, I forgot that there is a picture of the inside of the RFQ.
Oh, that's great. Okay. Oh,
See here,
here it
basically
is.
this is the inside of the RFQ. These are 4 vanes.
And you use
basically
these
a quadrupolar mode is excited inside. We provide the focusing, and then you see that there is this kind of modulation inside. This
Yeah,
ripple.
you're right. Yeah, those
This ripple is
little
what
ripples in
provide the longitudinal component of the field that provide acceleration with the focusing, which is the reason because it's a great thing. Honestly, it's a
So
great
you're
stuff.
using those little notches inside to give it, a little kick.
Exactly. So you are focusing and accelerating at the same time.
And those things are the one that we saw at the mechanical workshop before.
Ah, yeah, exactly. We saw those things being made live before, shortly before.
So this is why we build those things.
Yeah, exactly. This is why we need to be able to do all those weird mechanical things. I'll give you like one last show. I always loved these like attention, high tension signs around. Okay, you can
Once at the
reply.
power. On that side, for 2 tanks is 1 megawatt, and here, so it's 35 kilowatts. You said for this buncher.
This kind of amplifier is a solid state amplifier.
Okay.
And it is fed by one amplifier per each bunch and cavity. Each amplifier delivers up to 30, 35, 37 kilowatts.
Okay. Okay. Thank you very much. There was someone on the.
He said this one is fitted by
Non capito.
Claustro. Sorry, Claustro.
Okay. Thank you very much.
You're welcome.
Thanks.
Thank you.
Now we're heading back. Thank you. First of all, I would like to thank Vittorio a lot for being so available. You know, it's giving us a bit of time. So kind. Thanks. Woo. Now we're heading back. Grazie mille, veramente. Infatti sì, ti ringraziano anche dalla chat. We're very happy because it is kind of the first time that we're doing this kind of streaming from CERN and in general from like a research lab, and you know there's 1,800 people watching us even with the connection issues that we had before. So 1,867 in this very moment, person watching you. So it's a lot even for us. We're like a small retro gaming channel. We just happen to be lucky enough to work or have worked here. So thank you very much, guys. We'll definitely do this.
Guys.
Woo.
Okay, please leave the helmet.
Yay.
These one are like. Okay.
And this.
Okay.
Thank you very much. We can throw this here. These are the radiation locks in case of issues. This is where we
the
work.
access point.
Yeah.
And one by one you go in when you have to work inside. And that thing you see with the kind of a display there inside the door is actually an iris scanner.
It checks your retinas. It's a retina scanner to get.
Okay, guys. Thank you very much.
No, thanks to you. Thank you very much, Vittorio.
Good afternoon. Thank you for watching.
Thanks.
Don't go away.
They
Bye,
thank
guys.
you. They thank you a lot. They're super happy.
Have a nice day and a nice tour. Bye.
Thanks. Ciao. Okay, we're heading back, going to the data center. I'm grabbing my stuff. Do you have do you have a USB-C cable? Avete un cavo USB-C? Ce l'ho io perché il telefono mi sta un po' morendo. No, we didn't forget the bags. Someone said, don't forget the bags. Okay, it's okay.
Let's go.
Sorry. Thanks.
You have a battery bank or
No, I can connect it to the thing. I just need the cable.
okay. USB to USB-C?
USB to USB-C, yeah, because my phone is slowly dying. It's extremely, but we're ready for this. We're like dirty. We got enough energy to actually to supply power.
Like the mother of battery banks.
The mother of all battery banks.
This is like 20 amps hour.
Because in any case,
2000 milliamps hour.
shortly we will be doing a pause because there's the official stream from CERN, and we will pause for that. Flavio, can you keep the phone still? Just keep it like that while I press. Perfect. Okay, thank
Because
you very
at
much.
CERN we invented many things, but not teleport, and we want to move to the other side.
Yeah.
So this will take some time, and in the meantime you can enjoy the CERN official stream.
Yeah,
on
exactly.
Facebook and YouTube, I think.
Facebook or YouTube, and we hope, since there's like 1,800 people in this stream, I think there is some interest for CERN on Twitch. So we hope this is not the last time we see each other here.
Especially because at 5 more or less, even a bit before, we will be back until 7:30.
Yeah, exactly.
Guys,
We will be back until
just
until
a
they kick
pause.
us out, basically.
It's just a pause. We're not done yet.
Yeah, exactly. But we need to recharge a bit, even ourselves.
Yes. Especially because I started my shift as a volunteer here for the open days at 7:30 this morning. So it was a bit rough.
Okay, now we're heading.
So Stefan is at the data center. I don't know how much time we have left.
Yeah, but it's fine. It's okay. We have.
This here is the other restaurant.
Yeah, I'll show them a bit. Very interested. Yeah, people are very. Thank you, Appius. Grazie, Appius, per la sub. Ok, parlo. I'll switch to Italian for a brief moment. Alle 4 inizierà lo stream ufficiale del CERN su Facebook e su YouTube, ma visto che ci sono 1830 persone che ci stanno guardando in questo momento, io spero bene che il CERN cominci a streamare un po' della loro roba anche qui, e grazie a voi. Thank you very much to everyone for being here today. We're really humbled by this massive support, and I'll switch back to Italian, just to explain what we're about to do. Now andremo a visitare il data center, quindi i computer del CERN.
Daremo un'annusata, credo.
Daremo un po' un'annusata perché alle 4 interromperemo tutto per un'oretta circa per dare spazio allo stream del CERN. Fabio ha messo lo stream ufficiale del CERN. Fabio ha messo un link allo stream. Eccola! Guys, look, the beauty.
Our best sexy climber.
Our sexy climber now with 1,800 people watching you, man.
Oh, really? Everything's fine. You're enjoying the streaming and so on?
Yeah.
Let's go.
Let's go. We don't have much time, yeah.
Yep.
It's fine. It's okay. I think 5 minutes won't be an issue. 1,900. Yeah.
Wow.
It's kind of crazy.
Wow.
So how was Linux?
That was super cool.
Did you enjoy, guys, Linux? How was it?
Yeah, from the chat they seem to have enjoyed it, especially when I did a bit of machine porn, and I showed like the various components from close. Yeah, there's lots of people queuing. Maybe they don't want me to. What? And this is actually where I used to work here. This is one of the other buildings where I used to work. Ah, I can show the mouse. I'll show the mouse thing. This used to be like an Easter egg from, I think, 10, 15 years ago. Sorry, not an Easter egg, an April Fool's. And they do this CERN animal shelter for computer mice. And they did like this small shack, and inside there's like computer mouse. And there's like a whole tree of computer mouse that are forgotten, and they found a way, and they found a spot for them to rest. And it was supposed to be like an April Fool's, but it stayed here forever. And this is the IT. This is the main building of the IT. So
this is the data center.
And I used to work there. It's one of those windows at the second floor. It was my first office here at CERN. And here is the data center.
It starts from there, probably. No, that is the back checks, whatever. So
Can we get inside there?
Yeah, or you can show the pictures from inside.
Yeah, maybe we can.
No, from the inside you cannot.
No, you cannot pass by here. We need to cross.
There.
Need to cross from here. Yeah. And now we're heading to the area, or we hope that we manage to get into the area where.
Well, I do have access here.
Ah, you do have access. So, where most of the computer infrastructure of CERN is. So, I think there is the grid, the storage, virtual machines, everything. Almost everything is here, right?
It's like 9,000 servers.
9,000 servers. Also, there's the exhibition. Bonjour.
Faites une visite?
Ouais.
Il faut aller à l'entrée.
On est avec la presse, on peut faire une petite tour très quick.
Je sais pas, faut aller voir avec la tente.
Ok.
C'est eux qui vous diront. Ça marche?
Ok, merci. This is super nice. I show. Okay, so now it's the wrong area. It's the wrong area. You cannot pass by here, and we need to. We need to go. Yeah. Yeah, he kind of bounced us back. Yes. No. Why did it? No. Okay, so we'll try. I mean, we have to. We have to go from here and hope that the press pass opens some door. You shall not pass. No. Hi.
Crisis?
Is there any way for us to visit the data center?
Oh yes, of course. Please follow the flow.
Yeah.
So you have to go around.
Hey, how's it going, man?
And to enter by the back of the tent.
Ah, okay. Okay, thanks. Let's see if we manage to get in a reasonable time, because we need to leave for the actual.
So if you just join here, once the presentation's finished for the people in front,
Okay.
and you go in, you'll see a presentation and then tour through the computer center.
Is there any, because we're live streaming this with 2,000 people watching,
yes,
and we got a press pass. Is there any way we can get in just directly with the first thing?
No, because we have to limit the group size. Sorry.
Yeah, it will be just, again, it's been live streamed. We got the CERN official thing, but it's not possible.
I'm sorry, no, because there's
Okay.
lots of them with front.
Okay, fair. Okay, they weren't very kind with us, but that's okay. We can go and have a look again at the power converter area, or Linux 2. Sorry? Plan B. We'll go for a plan B. He was very... Yeah, he has no idea what live streaming even means. Okay.
No comment.
No comment. So yeah, we can head. Actually, it's almost time to cut the stream. We can try to. I don't know if because this is Linux 4, right?
Yeah.
There's Linux 2 somewhere else.
It's downstairs.
There was a huge queue.
Can
Huh?
we go back to your friend?
We can go back to my friend to see if maybe they're doing music with the Tesla. That would be nice to do again. It's fine. I mean, the good
We
thing...
only have like 5 minutes.
We only have 5 minutes, and in any case, there's so many things to see that even if we skip, we'll try, if this thing works, because this is working, judging on the amount of people that is here watching us, we will do this again for sure, maybe on a less crowded day. But if this interests you, and I think there is some interest, then we can replicate that. And people are looking at us all the time like we're weirdos, and we are weirdos.
If you wonder, it's the kid area there.
Yeah, let's show a bit Petrucci because he's handsome, he's the handsome one. So we need to show him.
30,000 views, bam! Spiking the views.
I mean, we have to show the handsome side of CERN.
Wow. No, come on, you can show the wine girl.
Yeah, I know.
Really?
We haven't shown you, but we haven't shown you, guys. I mean, we need to do this for girls or guys. I mean, it's...
Yeah, but come on, you need the guide in the center for the little day and you wanted to go inside another one.
Yeah, exactly.
Ours is better.
Yeah, I
it's
know.
much more modern.
Yeah. I have no voice left because I was speaking with the fan on. It was super noisy.
But you were inside this morning?
No, I was in the LHCb data center.
LHCb data center.
Which is made by 6 containers, just delivered. 3
They delivered
megawatts.
the last 2? Like yesterday, one.
Yeah, a few weeks ago they delivered the last ones. So we didn't have time to fill them up with the machines.
So you have to buy the machines.
Okay, we have to buy. Okay, but this is not like something you say, right? So we just showed the container number 5, which, yeah, it was super loud actually. Even though there were just one rack on, kind of.
No, but that loudness there is not the machine fans. This is the...
No, so it's the small fans.
I think we can... I don't know if we have time
we can
because
show
it's...
the Mont Blanc.
I think
Yeah,
we
and
can
then with the
maybe
Mont Blanc,
show the Mont Blanc and close it here because I don't think we have enough time to do anything from where we are. So let's do it like this. They should be...
What time are we going to reconnect?
Okay, it's easy. Let's just give a bit of explanation in both English and Italian. So now we will stop the stream from here, and we will invite you to go on and watch the CERN official stream. Kenobisboch, so us, so Fabio, just posted the link. It's on Facebook and YouTube, and we will be back once that stream has ended. So I will say in an hour or so. Yeah, they're streaming also on YouTube. So yeah, thanks Appius for the link. Please go there. We will be back in an hour. They'll do the stream.
You came from us.
Exactly.
Yeah.
Tell that you came from Twitch, please. That will massively help us because we'll show how much support we got here. And please tell them that. Please tell them that Twitch and Kenobisboch brought you there.
Last thing, we'll walk in the other side of
Exactly. In the meantime, we'll move to the other side.
We'll walk.
We take the
bus. Whatever. We move to the
we
other
relax
side
a bit
of
and we move to the other area.
And coming next, CERN Control Center.
Which is cool.
Amazing. Then the Dune experiment, which is also super cool. And eventually an A62 depending on...
If we have enough time. Yeah, you see it's a bit improvised. So, but yeah, I hope you enjoyed, and I'll see you all in an hour or so and on the CERN stream in a few minutes.